got forced to, and Excel changed its ability to export fixed width columns into text files. It like took it away. You have to use the column width, which looks like a pixel setting, to set the number of characters per column. It's totally unintuitive what they did. And I know you guys, being so smart, could work it out in 2 seconds, but for a monkey like me, it's like a 2-hour fiasco.
I basically gave up on Microsoft Office about when they started to do that online office thing.
Yeah, that's what I'm stuck with. I want to scream.
Yeah.
Okay, I'll see you guys later. Maybe I'll come back.
Yeah, you can. Come back if you can.
Thank you.
You can maybe try VisiCalc on a P2.
But where I'm headed, it's my future.
Pluto has CPM running. It is basically running. VisiCalc is running. WorkStar is running. Microsoft Basic is running. Just my COBOL compiler fails. I have a COBOL compiler for Z80, but that uses some undocumented features and they are not in yet. So no COBOL yet.
What is this running on, Michael?
On a Z80 emulation, original built by Pulmol, and Cluso took that and modified it for the P2.
Okay.
So we basically have a Z80 emulator running CPM almost. I mean, not yeah. Some instructions are still missing, but basically it's running. It's amazing.
That's pretty cool.
Yeah.
Chip, you were saying you were getting a Starlink connection. Did that come through yet?
No, we paid the money, but who knows when that thing will show up. They said Q2 or 3, they thought. So that's should be now. See, January, February, March, April, May. Yeah, we're into Q2 already, right?
Right, think so.
So it might show up.
Oh boy, well, I wish you well with that. My son picked up one and they're still geolocation locked. He wants to be able to travel with his and they have to unlock them yet.
Oh, interesting.
How much is that Starlink stuff? I haven't heard it yet. Monthly cost, what is it?
What, Mike?
How much is that Starlink connection?
Well, I think it's like $3.99 or $4.99 to get set up. So you got to send them $100 and then they put you on a list. And then when they ship you the hardware, they bill you for the remainder. And then I think after that, it's like $99 or $89 a month.
Yeah, it's about what I'm paying right now. Yeah.
Yeah.
That's
Oh, I'm
kind of, here in America, internet is so effing expensive. In Germany, all my colleagues I'm working with, they can get internet for $20 a month or 15, and I pay what, 92 for Mediacom.
Yeah.
That's kind of, they rob you here in America. Same with those cell phone contracts. My sister has a cell phone cost her, I think, $8 a month, and here it's even prepaid 45, 50, something like that. I don't like, I don't know. It's one of my most heavy expenses currently is water, $180 water a month.
That's your water bill?
Internet. Yeah, my water bill is $180 a month. Unbelievable. They robbed me here in that area, and you are not allowed to switch. I mean, a friend of mine even has an own source and an own well and an own sewer system. He is not connected at all to city water and sewer, and still has to pay $120 a month. Yeah, they have kind of a right to charge you as soon as you have property.
Yeah. Hey, we're at the hour now, and I see.
Yeah.
Oh, where was he?
Tubular is there. Lachlan
There he is. All right.
There he is. Yeah.
Oh,
Morning.
Lachlan. Oh, I'm looking. Hello.
Good morning.
I switched myself off.
Good afternoon. Good evening, I guess, for most who are here. Yeah, we've been working on a MikroBus module, a MikroBus breakout module, which can be used with both the P1 and the P2, and also rack mounted. So this, I think Ken sent around a photo in the mail out recently, but this is in what's effectively a 2U Euro rack height case. This case is fairly shallow. It's just made with just the rails that you normally buy to assemble a larger case. And what we're planning to do is there'll be more than one of these, like they'll be cascaded across. You can see like a different variant over here that we've been doing some testing with. And this is the one with the which we're currently working on with the MikroBus slots. The MikroBus is fantastic in that there's about 1,000 different modules out there now, and you know, there's a really wide variety of everything from memory chips through to you know, displays and input devices, and a lot of signal conditioning. You know, things like load cell amplifiers. There's about, you know, 6 or 7 different varieties. There's, you know, about 6 or 7 different varieties of you know, light ranging modules. Just about everything you can think of, there's multiple variants, and so it makes it easy if you're not sure what device to choose, like at that stage of a design, then you can sort of just plug in different modules and try them out before committing to a particular one. So yeah, it looks like a slightly weird module because of those mounts, where the mounts sit on the edge, but that's why we're doing it, to make it so it's, you know, kind of modular and cascadable.
So how many, Lachlan, how many pins does each of those take from the P2, or is it kind of variable?
Yeah, so each one of these takes 12 pins, and Johnny Mac and Von Zarvis, I think, worked out that pin out. You know, so they decided they would just use 16 pins from the P2 to drive each module in a non-multiplexed way. A lot of them, the official microelectronica products, they kind of multiplex up some of those pins. So you might have, you know, say I2C going across multiple Clics, but with the P2 you've got enough pins to break them out individually. Yeah, so it makes it sort of it takes advantage of the P2's pin flexibility to just have, you know, 12 pins going to each module.
That represents 72 pins, doesn't it?
Yeah, so we just on pins 5 and on Clic modules 5 and 6, we did actually multiplex up the modules. So what we did here, we actually took, you know, 12 pins for P1, 2, and 3, 4. Each one is off a 16, a 16, like a word of I/O, and then we came back and used like P12 through to 15, and, you know, so the 4-bit nibbles are used to make up the Clic 5 and also Clic 6. They're kind of in parallel. And so yeah, we kind of, when we laid this out, we're initially targeting just 5 modules, 5 Clic modules, but there was this kind of hole on the circuit board, and it just looked a whole lot better if we just duplicated. And so we did kind of compromise on, I guess, the number 6 module, but you know, it's better to have it there. And if you're using I2C or SPI, you know, that's better than not having it there. So and there's many of the Clic modules use I2C. So it's not really that much of a compromise. Yeah. So,
yeah, I like that you have a rack mounted thing, because that is something I'm missing pretty much. Because a lot of installations I'm working on are rack mounted, sort of.
yeah, I'm a late convert to rack mounted flexibility, but I can see, you know, for something like this where you just want to grow and you're not sure how big you want to grow, or how, you know, you might have 2 directions you want to grow in. It makes a lot of sense. You know, you can just and you can buy all this hardware off the shelf already. So, you know, to the developers of Euro Rack and really the rack systems before it, I guess, because this stuff goes way back. I'm not even sure where it originated, the rack development, 19-inch racks. I mean, it's been around for, you know, for ages. So yeah, but it certainly makes for a nice system. The only thing we're looking at doing, I looked at, there's 3U racks. But this is like your normal sort of 3U rack system kind of thing. And, you know, that's what your hard drives and everything were designed around fitting in these racks, 3.5-inch hard drives. So it's just too big, you know, for P2 circuit boards. And so we looked at it and we thought long and hard, because they're readily, like 3U's a really common height. We decided this would be, you know, this is a 2U rack, and of course, you know, 1U, which is also reasonably common. But the 2U ones are a much nicer size to use. It's kind of not that much bigger or wider than your mobile phone, and you know, it just makes for a nice kind of form factor. I guess it's fairly similar to you know, Parallax's you know, your proto board USBs and things like that, which have been made over the years, which are about 4 by 3 inches, I think. Sorry, they're 6 by 4 inches, roughly. Yeah. So yeah, Euro Rack.
Lachlan, how do you connect the P2 over to those 6 boards? Is there do you use a ribbon cable, or do they abut and make a connection, or how does that work?
No, that's just circuit board routing from, you know, so when we load up this board, the CPU, whether it's a P1 or a P2, is always over this side where the P3 and 4, where the Clic 3 and 4 modules are. So the CPU is over here, and there's tracks which take all those.
It goes on the back side?
They take it across to here. So this is like self-contained, and the CPU, which is on here with its 32 or 64 pins, is sort of moving across to these sockets, the Clic sockets, and also we've got accessory headers, like P2 accessory headers around the outside. So for every I/O pin that originates here, we're going to 2 locations, one where the Clic module is, and one where the accessory module is. And they're in a slightly different order. Now I'm going to try something really low tech here, and I'm just going to hold up like a map, a drawing. I forgot to take my laptop home last night, and so this is like kind of a low tech way of doing a slideshow. But hopefully you can read that okay, and you can sort of see where the Clic modules are and what their I/O locations are.
Is that an edge connector on the side?
No, at the moment, this is we can make an edge adapter for it, and we will make an edge adapter. But at the moment, that's a P1. That's a P1 chip loaded in there. It might be better to cut to the. So this is one we've loaded up earlier, and so this actually is with the P1 loaded up, just because it's sort of easier to get up and running and prototyping with initially with the P1. So it's a P1 DIP 40 on covering those slots 3 and 4. And there's an EEPROM and a crystal underneath, you know, so there's a socket which elevates the P1 slightly. And, and you know, like was done on, say, Phil's prop stick, you know, where the EEPROM and the crystal and, you know, a couple of pull-up resistors and things are located underneath the P1. It was actually a late design decision to do that. We were just designing it around the P2 DIL 80 breakout module, which we made up. And we decided actually it makes sense to also let it be driven by a P1. And when you drive it with a P1, it's actually not that compromised, because you have access to the 12 pins driving this Clic 1 module, and you have 12 pins driving Clic 2 module. And then for P12 and 15, which come from the middle there, they actually power the I2C and the serial RX and TX pins on these slots 5 and 6. And so you sort of get, you know, up to 4, but quite easily, if you've got 2 I2C modules, you can have 4 Clic modules, you know, supported there off a P1 chip. And so that's actually a pretty good, considering it just worked out well due to that, the way P12 connects onto those last two sockets. So yeah, so I'll fire this up. This is really just demoing the blinky LEDs of the WS2812 LEDs. But we may as well do it. So okay, so just run. Can't really see here, but there's some P1 code running off to the side in Propeller IDE, and I'll just hit go on that. And so that's just, you know, exercising the LEDs on there. I was going to hook up the light ranger so, you know, you could have some kind of interaction with it, but I haven't quite got the, haven't had the time just to pull it all together, but we'll do that in the next week. Yeah, so that just, you know, we've just been checking that the IO map's okay and everything on the P1 before moving across to the P2. We'll be able to sell these boards pretty cheap because there's not a lot to them. Like there's a breakout board, you know, the board itself, it's really just got some Clic module sockets on there. The Clic sockets, they're a pretty neat little, these are something which Microelectronica sell, and they actually print like the pin labels on the side. So if you can see there, the you know, the pin functions are actually labeled, printed, screen printed onto the side of the sockets. And Microelectronica, they charge, I don't know, around $1, I guess, for these sockets, but it does make for a nice result. And the other thing which is kind of hard to see from the angle there, but might be able to get an angle. So they kind of raise like the back of it so that when you plug the Clic module in, it kind of sort of, it does actually kind of click into the socket and it makes a really good solid mating. Yeah. So they're a you know, we like using them there. They seem to be a nice little product. Yeah, so yep, that's what we got. Now that module's been removed, you can see under Clic module 6, there's an encoder wheel. This position, which is just sort of in here, that's for a 16-way rotary encoder, which we can use with the P2 for setting address. And so when you've got more than one P2, Brian's been working on a loader which can load up, you know, more than one of these on a sort of a party line. Effectively, it's a sort of a prop plug party line where you've got RX and TX carried across multiple modules. And so with the P2, Chip was far-sighted enough to put in that right into the loader so that you can have, when you're doing a prop text or a prop hex loading command, you can set an address mask, and that means your code will only go to you know, a particular module or a few modules which have a matching address which match the mask. So the idea is that when we cascade these, and we've put some IO pins on the corners which will enable, you know, this to be connected to the next, at least the prop plug bus, so to speak, will be connected across modules, go to the next one in line. So we'll be able to sort of address individual boards if we want to. So we're kind of preserving that hierarchical system, and we've done a bit of work. You know, we're just trying to get the board rate, the loading rate up on those, and it sort of depends a bit on the capacitance and length of the cables, as you'd expect. So, but it certainly does work, and we're using that and spending some development time on it. So, yeah. So I think,
great.
Do you have a link for those labeled sockets?
Yeah, I'll put a link. I'll just they do them in black and grey, so you have a choice.
Oh wow.
Hey Lachlan.
Yeah.
I had sent to you an email a couple of days ago about taking care of the your boards in North America, and it sounds like it may maybe you got more stuff to go into the parallax.
Yeah, Jim, we're we're getting it all together. Hopefully in July we'll have some you know, some stock to ship, and you know, the more places we get out there, the better. So yeah, happy
Okay.
to see stock and Parallax as well, and you know, wherever else. It's sort of, we're kind of creating this stuff because we need to use it ourselves. But once you've created it, of course, it's not that hard to share it around and support it because you're actually using it. So yeah, I've got the.
Yeah, if you need to get to North America sooner than later, I know Ken's busy right now, but if you need for me to get stuff up to North America,
The express
I'd be
service.
I'd be happy to do that.
Yeah, great. Whereabouts are you located, Jim, in the US?
I am in Nashville, Tennessee.
Oh, wow. Okay. Yeah.
Music City.
Mm-hmm. Yeah. Well, hopefully, as I said, within a month or so, we've actually got about 20 of these boards which we're playing with, but we'll probably chew through, you know, 5, 6, 7 of them just in development, and then the rest of them should be spare. We've got plenty of sockets and things to make up, you know, that first kind of batch. Yeah, we just, you know, we're working through it. It's probably not our top priority right at the moment, but we've been working on the addressing side of it, making sure that works, and then we'll finish off the stock in the coming weeks, and you know, hopefully get a shop up in July, web shop. So yeah, by all means, we'll have stock to move around, and same goes for if there's someone in Europe who's looking to you know, be able to distribute these, and that would be fine too.
I can probably ship them cheaper than Ken right now.
Yeah. Yeah, it's I mean, yeah, it's something we realize we'll work through, you know, distribution, but no, we'll take a pretty you know, prioritize just getting products out there. I think with the P2, it's such a good chip, and there's so much it can do, but it just you know, that it needs to have different form factors or things that, you know, to enable people to latch onto it. And obviously with the Clic modules, there's a lot of people who've got an investment already in several Clic modules. The same goes if you're using FPGAs and the PMod, you know, the PMod devices for FPGAs. And of course, DIP 40 chips, everyone's got a few of those, right? So yeah, it's good to kind of preserve, or to keep using, or to you know, to get some traction, just get using stuff that people have already got. So you know, the Clic ones are a good way to go. All
right, well, carry on, my friend. You're doing great stuff.
Yeah, thanks, Jim. Cheers. Yeah, so there are other questions about the board or the form factor or any aspects. It's no, I haven't got the shiny presentation we did like last time, but it's a fairly straightforward breakout in that we're just moving the I/O pins from one side to the other, and yeah, it'll become probably more interesting when we actually start doing some real world kind of hookups and you know, using multiple sensors to do things on it. So yeah.
Well, it's a great idea to have both a P1 and P2 support for it. That'll certainly broaden its availability or usability.
Yeah, so that was when we were developing that P2 DIL 80 module. That one of the things we're trying to do is preserve, because we have a number of P1 boards which take a DIP 40 prop. We wanted to, if possible, be able to use a P2 just to pick up and use those same boards. And so that was kind of the priority, was to make sure it had P1 footprint compatibility. And the way we did that was just adding, so, you know, you've got your P1 footprint on the inside circle, and we just added a second row of pins around the outside for doing the P2, like port B, in effect, you know, P32 up to 63 around the outside. And so that means we can go back and put that module into our P1 designs, you know, of which there are quite a few. And you know, a lot of the boards, this smorgasbord product we did, the board we did years ago, which had a number. That's got actually quite a few. There's probably about half of them have got P2 dip 40s in there. And so this sort of preserves the, you know, the life of any of these designs. It means that, you know, you can put a P2 in there and have that up and running. So yeah,
I've got 2 of those if anybody wants to buy one, or for free.
yeah, for free. So that's probably about all I've got on this board. If anyone's got questions, or otherwise, if anyone's got a design or anything that they're working on that they might like to share, it might be a good opportunity. Anyone's out there working on things?
I've been working on the floating point, but not so much of late. I've had quite a few exchanges with Eric Smith, and he's got me straightened out on all the different, you know, not a number values and the rules for equality checks. We really do need a floating point equality check because, you know, -0 equals 0, but not a number doesn't equal anything, not even itself. So there's some funny like corner cases to handle. So I was working on that. I thought I'd have it done a while back, but I got delayed. I wasn't feeling well, and it got worse over a couple of days, and it turns out I had pneumonia. So I went into the hospital for a few days, and they gave me all these antibiotics, and I came out just fine. And then it kind of like reset me in a way. So I figured before I get back into coding, I got to like get a few things organized and get on top of things. So I've been cleaning my office. My son's been helping me. It's like 10 years of accumulation, and it's all in exploded mode right now. Now I got to like reconsolidate what we're going to keep and get everything else out of here. And then I'll be able to get back to work in a clean environment. So I've kind of just taken a detour, but the next thing I'm going to hopefully have finished is the floating point, and, you know, built into Spin 2 using special operators. So I haven't really gotten much done the last couple of weeks.
And it looked like you got a nice clean haircut too.
Yeah, I'm back on a plant-based diet, which I used to do a while back. I just got to get myself completely as cleaned up as possible so I can function.
Looking good.
What's that?
Looking good.
Oh, thanks.
What's the state of that motor controller?
No progress my end at all.
Oh.
This floating point's kind of a detour. It's here on my desk. Take a look at my desk. I had to like work a few minutes just to be able to come and sit down in here. This is I even had to push some stuff out the door so that I could sit at my desk. So everything is on kind of hold now. I want to get this office cleaned up. And this is like resetting my brain, you know. This represents all this accumulation is just a drag to think about. So I want to get it all out of here and just clear everything off, vacuum all the corners and dust everything. This is inside of a barn, and the dust buildup is incredible. Everything gets really dusty. And I've been wanting to do this forever, but I just wasn't like up to it. But after all that pneumonia business, and I'm kind of getting reset, I just want to take care of all this, get this all straightened up.
Chip.
We've got hundreds of pounds of junk out of here already.
Chip.
Yeah.
Enrique, do you have a friend that sells a service, if I remember right, of flushing the air from environments? You said something a while ago about he being able to flush the air from an entire home with their machines.
Yeah, you know, I know some guys that do that, but I think they probably have an expensive system they're selling to institutions. It's not something I would afford, but way over there in the corner behind the drums, there is this HEPA filter that just sucks in all the air and filters it and blows it back out. And I need to get a new filter for that thing and just leave that thing turned on all the time in here. It should keep things clean.
Okay.
Yeah, This is a really dusty place where we live.
You don't want to never come here because I live inside the dust. My
Yeah.
lungs are too filled from smoke.
Yeah,
So,
yeah.
yes, the dust needs to adhere to something to be expelled out. If you have your lungs too clear, the dust will settle inside then.
Yeah, yeah. It was weird when they had me on those antibiotics, it was like 60 hours and it like completely reset my system. I didn't have any kind of like phlegm or any congestion or anything. And then after a few days of getting out of there, the environmental stuff starts working on me again. And I pick up the usual phlegm that I always have. But for a while, I was like completely kind of cleared up.
I
But-
used to drink a lot of water during the day, about 3 liters a day, even in the winter, because to keep my body full of water and my lungs too.
Yeah, I've been drinking a lot of water and I've been okay. Just lost a bunch of time. And then we just went on a family vacation that we had planned, so that was nice. We went out to Tahoe and the air there was thin, but it was cooler. You're gonna come back to Red Bluff and it's just so hot here. It's gonna be like 114 next week.
Oh my gosh.
Wow.
Hot and dusty.
Yeah.
Well, I've been on a wire reduction crusade. I'm working on some Clic modules. Can I show you what I did?
Yeah, that'd be great.
So this is it's just silly things because this is the standard Clic adapter for the P2 eval, right? But then I needed logic analyzer. And so I put exterior pins on it, right? So now you've got pins that map directly. So it's real easy to work with the modules. The Lachlan, when you have those labeled headers, it's like, oh, wait, I should put those in the middle there. They have a through hole version there. And so that would work very, very well on that. And then while I was thinking about that, Michael suggested that, if we're doing LA, what about for any adapter? And so with standard eval single boards like the LED module, how do we probe any of the modules? And so I created a second one.
Oh, nice.
And so they actually come as 3 boards together on a little pad. And so now you can just cascade them and have a logic analyzer connector. I'm assembling things while I'm talking here. Good. You have to kind of match the holes though, don't you? So now you end up with things like this, but you've got logic analyzer connector right here in the center that you can play with and have anything outboard here. And these things are spaced well enough that you can do dual modules as well. So I got tired of having flying leads all over. I'm working with 5 or 6 different Clic modules, and it's like every time I have to rearrange all the flying leads, and it's like, yeah, no, I'm not going to do that anymore. So I just threw together some boards. So kind of fun.
That makes me think like we should, if we can ever build another chip, we should put a lot of the IO stuff so that it always just works in parallel. Like, maybe always have some kind of logic level input enabled rather than have to mux between what you want. Always have like a few things always enabled, like the ADD can always run in the background, the DAC could run, so that you could do captures like the logic analyzer stuff without even really needing the lead, so that you could then output it in some other format, but you could capture it at full speed.
Yeah, interesting. We have the constant issue of the cheaper logic analyzers don't do your 3.3 volt threshold. The little $20 ones. And so now you've got level shifting up to 5s just so you can run the $20 logic analyzers.
Oh, do they want 5 volt signals? Is that what they're up to?
Yes. So it's a little USB attached, cheapy, but it gives me a greater depth than some of my mid-range logic analyzers. And so I now have these the standard punch blocks that we have with 5 volt level shifters, and I just route through them. I didn't even think about adding a level shifting on these boards. Silly me. But it works. So I'm having too much fun. I'm working on the 9 degree of freedom MPU based Clic module. I've got the P2 OBEX driver ready, pretty much ready for that, but we're still, Chip, you helped me with some of the math. I have to prove the math after I prove the values correct from the chip. And so I also need repeatable positioning so I can run some tests and check the values. And so silly me decided to play with a 6-axis arm to hold it. And so now I can just position the arm in all the different positions I want for the 9-DOF board, 9 degree of freedom board, and then take readings over repeatable tests. And so I delayed myself even further by doing a I2C to 16 channel PWM P2 driver as well. It's actually an LED chip that they use. And so I'll have 2 objects coming to P2 OBEX for those 2. And then I also have the light measurement chip, which is an SPI based chip. And I have a driver for that as well. So over the next week, I'll probably push those 3 to P2 OBEX so people can play.
Neat.
Just been doing strange things.
Did I hear that right? 64 PWM channels? Is that
No,
right?
16. I slurred that probably.
16. Okay.
It's a single chip that drives 16 and it's I2C attached. And so you just tell it what, and it runs at, I don't know, select 400 kilohertz or something like this, 20 to 400. And so you can set the PWM rate. And so I developed reading the data sheets and making that work was only entertaining because it's written to drive LEDs, RGB kind of LEDs. And so it's, but everybody sells the board for servo control without any real examples. So I got it working, no big deal. So now I have an arm throwing my motion sensor around, hopefully holding onto it well enough it doesn't let go of it, but you know.
This will all kind of work for that cube project, right?
Yes. Yeah, the net result is we need what orientation is the cube sensor, and then the 9 degree of freedom Clic module has the magnetic sensing as well. And so we can, from absolute standstill, know what our orientation is relative to Earth magnetic once it's calibrated.
Yeah, yeah.
So there's a 6 degree of freedom Clic module as well, but that one is inertial only. So that would be less useful for the cube project.
Does the light sensor, could that work through the corners of the cube to kind of pick up ambient light to be able to control the brightness of the cube?
Sure. I'm looking that way because you're bending my mind's imagery here. Yeah, it's a lumens, so yes, it's relatively broad spectrum. So sure, you could if you wanted to. Inevitably, your hand will be over that corner while you're holding the cube, so that'll be interesting. But yes.
I wonder if the like picking up the Earth magnetic field kind of thing will be affected because you'll have currents driving the display panel. So I guess, I mean, you could probably turn off the display panels for a moment while you sense your orientation. Maybe it'll be interesting to see if it can pick out that.
Yeah, that's a really good observation.
I
we'll
wonder,
find out.
or maybe the thing filters enough, because all those magnetic fields are very transitory, right? They're kind of high frequency, but the Earth magnetic field's pretty constant. Maybe it can filter it. Maybe it already does that just because it's common to have, local magnetic fields that are always changing, that would otherwise be interfering with the compass.
You raise good questions, though, for sure. Makes me want to have one to play with and figure it out, but I have the flat cube. Other people have the cube. Mine's a linear six-sided, 6-panel piece. And I haven't 3D printed the parts yet. But
When you want, Stephen, we can go over that code again. Remember, we were on the cusp of making it so that we could place the clock anywhere in relation to the phase of the data.
yes,
We can do
you're
that.
talking about the LED driver.
Yeah, the
Yeah.
driver. And also, I think that the for doing that 9 degree of freedom reading, floating point would certainly be a help, wouldn't it? It would just
Oh my gosh.
take
Yes,
away the need to try to determine how to do the fixed point best.
yes.
Yeah.
And so so I kind of took a break and did these other things with the hopes that maybe you would zoom right in there with floating point. I wouldn't have to worry about the integer conversion.
Yeah, just hold on, we'll get it done. It was when Eric Smith was telling me all these little corner cases, I was just thinking, oh man, maybe this is just too much for our implementation. But then thinking about it, I realized now we should do it that way because you really do kind of have to trap underflow and overflow.
Correct.
Otherwise, you can get into some weird code situations. There's no perfect, it's imperfect. I mean, you can't have a runtime error exactly in an embedded system because there's no one to observe it and deal with it. But you should be able to generate nans, not a numbers, and then they could be tested for if
Correct. You have to give us the ability to test for those conditions. We're always taught in embedded systems, don't ask the question unless you're prepared to deal with the answer.
Yeah.
Right. So we want at least the ability to ask the question. So when we have an ability to communicate failures or need to work around the failures, that we can do so. And so,
do you know how you detect a NAND? How do you? Eric told me that the rule for detecting a NAND, it's funny. It's very simple. It's almost under the radar, but you just basically say, does X equal X? If X is a float that's become a NAND and not a number, the X equals X will fail.
Interesting.
So that's how you detect if you've gone out of bounds.
Mm-hmm. Mm-hmm.
And anything, and then the rules for all the other comparisons are the opposite. It's greater than, equal, less than, equal. All those become false. Is that right? Yeah, they all become false.
Yeah, all comparisons become false when a NAN is involved. And also
except for the not equal, that becomes the opposite. Right?
No, I think they all just return false.
But I think that the not equals is the one thing that's opposite of everything. Because if you had X was if X was a NAND, and you said X, you asked, is X not equal X? What should the answer be? True.
I think it's still false, because I think NANDs are undefined, and so it is not equal to X. But I don't, you'd have to read the spec for IEEE 754 to really know exactly which one was which. But the other thing that's interesting is any math operation with a NAND as an operand results in a NAND. So
right.
X plus Y, if either of them are NAND, the result is NAND. And
so it puts all these little extra cases you have to check for in the code.
There's also plus and minus infinity, which are explicitly defined in the spec. And when they occur and when you do operations with them, they have alternate results also, operations with an infinity equals an infinity, no matter what, things like that.
Okay. What about 1 divided by infinity? Does that equal infinity?
I'm not sure what that is. To be honest, probably infinity, yeah. You know, they have plus and minus infinity also. So the sign bit still means something with infinity.
But would infinity, I mean, I wonder how you arrive at infinity, because NaN is an overflow, right? Like you exceeded the bounds.
No, NaN is not just an overflow.
It's actually a part of the range of the floating point, right? Technically.
Yeah.
Like if you have a number that's larger than a float can express with an exponent, that ends up with not a number, I think.
Yeah, that's a NaN, but how do you specify infinity?
Certain cases, it's in the spec. There are certain cases, certain math operations result in infinity instead of NaN.
Like a divide by zero, maybe.
No, that's an exception.
Nobody likes divide by zero ever.
Well, but see, this is an embedded system. If a divide by zero happens, and in our case, maybe we don't have exceptions to handle it.
Still reports, you still should be able to detect an error so we can do something about it. Yeah.
But maybe
it may be that one divided by zero when you have the exception blocked results in infinity. That may be true. We'd have to read the actual spec. Sorry, I'm late. I'm working in the office now, and I had to.
Right. Real work.
Yeah, so there are some things that need to be ironed out about this. But, you know, Roy, what about this?
So the question I have is all this float discussion mean that you're actually building float operations into spin too?
Yes, and we're doing so by using like plus dot, minus dot.
Yeah, you made new operators because you don't want to have types.
Right. That's right. And then we have
at least that's cleaner than f add open parentheses parameter 1 parameter 2 close parentheses.
Oh yeah,
right?
there's less to complain about, and you do get order of operation correct, you know.
Yeah.
And
it ends up resolving it correctly, just like as if it was a regular plus. It's just a different operator.
Yeah. Yeah, and then we're going to have some floating point like commands like sine, cos, you know, tan,
cool.
power,
and
things that
you
imply
should
there's
have
a floating point type thing.
Right, and so you probably want to do some of the most commonly used stuff like floor and seal, and seal meaning ceiling.
You know, what is floor and seal?
So right. Floor means
well, what is that?
It rounds it to the number going down, right? So if it's 1.563, it becomes a 1. It's the largest integer that is less than the value.
Floor is truncate, right?
Well, not really.
Oh, why not?
Because the sign matters, I think, with floor and seal.
Oh, so floor and seal rounds toward like floor.
I think they round towards and away from 0, whereas trunk just lops it off. So -1 stays -1, right?
Okay, so floor.
So like -1.5
good catch.
Becomes -1 with trunk, but floor becomes 0. I'm pretty sure.
Okay, so floor rounds towards 0, ceiling rounds away from 0.
Then
like -1.5 becomes 2 in seal.
I believe so. -2, not 2.
I mean -2, yeah.
I'm pretty sure that's the case. I don't use those. I mostly use floor, and I mostly use it on positive numbers. So,
okay.
But I'm trying to remember. There's some other basic float ops. I mean, I assume you're going to have some kind of convert to int that does either the thing that you can set on most other processors with float though is how it rounds, whether it rounds nearest or rounds by truncating when you do the convert to int.
Do you ever use those in programming?
Yeah, I mean, C defaults to round to nearest, I think, when you cast, but sometimes you change it. There's actually like a couple different rules. It's kind of weird. Depends on the processor.
Okay.
You should probably just define it as when you cast to int, it does this, and it's either round or trunk.
Yeah, we'll use the keyword. Ceiling is C-I-E-L typically, right?
Yeah, C-I-E-L.
Or do they spell out ceiling?
C-E-I-L.
C-E-I-L? Oh yeah, see, okay. All right, okay. More little giblets to integrate.
I would definitely look up all of those actual exact things. You know, like what does it do in each case so that you implement it in a more standard way than what I just remember off the top of my head, because I'm not the spec, so I don't know all the details.
Where would you look for those? The ANSI man pages or something, or what would you recommend, Roy?
Well, all the floating point stuff, you just go to the IEEE 754 spec. For what floor and seal do, you could look at just, you know, ANSI C specification or C++ specification, either one, or just search wiki, it'll tell you.
All right, well, this will be implemented in assembly language, and then the interpreter will have some bytecodes for it.
Yeah, no, that's all really cool. I wish you had done that in Spin 1, because even though it would have been slow, it's really handy to use floating point.
Yeah, some things like these accelerometers really need this kind of, they need floating point just to keep the programming sane.
Yes, please. However, I did find code examples for the, oh my gosh, Quaternion stuff.
Oh, Quaternion.
So while I'm not understanding it yet, I at least have examples for what in the world people would do to use.
So I've been using Quaternions for almost 25 years, and I still don't understand them because they are not understandable. Quaternions are like 4D. It's you can't wrap your head around them correctly.
Then I don't feel
you can,
that way. Thank you.
You can understand how to use them and where their use cases are handy, which we use them for skeletal animation and other things in games because it avoids gimbal lock when you try to use Euler coordinates. But trying to understand how they work internally is difficult.
Wow.
Well, it's some kind of a matrix formula, right?
It's not even that exactly, but like I said, I know people that are way stronger in math and programming than I am that have been using Quaternions even longer than I have, and they still say you can't really understand them fully. They're just a weird concept.
I wonder how they got invented.
It was kind of, they got invented, from some higher math, and it was more like they just work. So a lot of things in math are discovered by just trying things, and they just work, and then they never fail. And so they go, okay, well, this is good. And then they figure out the proof later, right?
Right.
I'm sure that there are people out there that get them, mathletes, as I like to call them, super, postgraduate math major people that might get them, but most of the people using Quaternions don't really understand them.
It's like compound interest or something.
All right, the can't remember his name. The guy the quadcopter.
Jason Dory.
Jason, yes, Jason was pretty good at doing that. Crickets.
Andre
Jason,
Lamothe talk about those.
I looked at that code from Jason because I was interested in those Quaternion mathematic thing, and I wasn't able to follow it. But maybe you should talk to him.
Hey, you know, I wonder what the, because you know, COBOL was very textual, like this time this, giving that. I wonder how you'd express quaternions in COBOL.
I'm pretty sure you can.
You probably can't.
There's no language. Yeah, you can't do it.
No, you probably can't. I love this language to this, but it's
My favorite thing with quaternions is that you slurp them, which is spherical lerp. Spherical linear interpolation. It's when you want to rotate something around a center point, you're moving the end of the point along the surface of a sphere, right? And so the quaternion follows that shape. If you just do regular linear interpolation, it won't follow the shape of the sphere. It'll go in a straight line between the 2 points. But spherical linear interpolation goes along the surface of the sphere, which is what you want for quaternions, because you don't want them to change scale as they rotate around. Learned that in 96, something like that, when I was writing an animation system for a baseball game back then. As the joints were animating, the legs were getting shorter and longer as they walked, because we were doing linear interpolation on the rotation of the bones. We had to add circle linear, and then it fixed it all. So I missed Lachlan and Brian's little board presentation. I'll have to watch the playback when it gets up on YouTube. I was trying to get home in time because I wanted to see that, because I'm excited for that particular board. You can use the Clics with P1 or P2. I assume P1 is on a flip, right? You just plug in a P1 chip. Okay.
exactly, yeah, and then you
That's
have
a P1 dip.
four of the modules instead of 6.
Can you plug a flip into that socket instead of?
Yeah, you could plug a flip in. It would work as well. And the P2, like the P2 DIL 80 board, which plugs into that same area, that also works on the same sort of power in pin. So yeah, you could use either one of those.
Sweet, that's very cool.
Yeah, and it means we've got kind of from the same board, you've got a kind of a really low cost option. If you add your own DIP 40, then you're not sort of having to pay for that to be surface mounted into the price of the board. So you know, we'll be able to make a a nice cheap kind of starting point for starting with the P1 and migrating across to the P2.
Yeah.
I have to look at Johnny Mac's code that he's come up with the Clic modules on the P2 and see whether they can be fairly easily adapted back to the P1. I don't think it's not going to be rocket science to get those that code working on the P1 as well. But yeah,
Should be fairly easy in most cases.
I would think so, because it's just I2C and SPI, depending on.
We already have those on P1.
Right.
Yeah, I'm pretty sure Johnny Mac was not using kind of the smart pins to do most of that. I think he concluded that just having readable code and sort of bit banging things was the way to go. But I need to double check that. Yeah, there's not. I mean, Roy, really, there's always a CPU across on this side, whether it's a P1 or a P2. And for every I/O pin, it's just bringing it across to both a Clic socket, which is usually sort of one-to-one mapped to Clic sockets 1 through to 4, and then 1 through to 5, and then the Clic socket 6 is kind of in parallel with Clic socket 5, which makes it useful just if you're doing, say, I2C or maybe SPI or something like that. But yeah, so we've also got parallax accessory headers around the outside for, or 6 of them out of the 8 anyway. So it's really just a mapping or a breakout kind of board that puts it in a useful format. And the other thing is like mounting it in a 2U Euro rack kind of format.
Yeah, no, that's very cool.
Yeah.
And are the little 12-pin connectors around the edge the same as the 12-pin connectors on the P2 board variants?
Yeah, that's right. And so the ordering is slightly different in that, you know, I mean, the Clic modules, they go, you know, 1, 2, 3, 4, 5, 6, they go in a clockwise mode, but the mapping on the, like this is P0 through to 7, this one here underneath here is P8 upwards, so they kind of go in the opposite direction, which is like the P2 eval board.
Yeah.
Yeah, so it's kind of what, you know, it's a horrific job from the track point of view, but it comes out easy enough to use.
Yeah, you must have fun routing that.
Yeah, it was not terrible, not the worst one I've ever done, but yeah, it just you know, we couldn't. I think it'd be really difficult to get the last remaining 2. You know, there's a couple of little compromises there, but the compromises are pretty minor overall. So. Yeah.
Cool.
Lachlan, you mentioned that you're doing the shared serial bus for programming the various P2s that you have, that they're sharing lines and doing addressing. Have you published, will you be publishing the driver for that selects and the electrical spec for that shared bus? Are there any R's and C's, or is it just parallel?
It's just in parallel, and it's sort of already in the documentation. You know, where Chip describes the prop check and prop hex loading modes and the masks. So it really isn't really going beyond. It's already kind of built into the P2, and so there's not really a lot to describe in addition to what's in the documentation. It's probably the only thing missing is kind of probably an example, like just a schematic and the kind of some test code and stuff, which
yes.
You know, Brian's written a neat little utility which lets you kind of see which ones are online and which ones aren't, because when you've got he's had, you know, stages, you know, just an array of wires which are hooked up to 8 different modules, and you know, not every wire always makes good contact, and so some modules will drop out, and so he's got a utility for loading these in. But yeah, at this stage, you know, we're just sort of using it, I guess, and finding out where the limitations are. But so far, there's no showstoppers. You know, it really kind of just works. It's just like you expect. The bus capacitance or the length of those lines will have some kind of impact on achievable baud rate.
Right.
But yeah, we haven't struck anything other than a minor addressing thing where you don't want to use P0 or P1 to set your address. You know, that was the only kind of thing we found, and you just, you know, given you've got 64 pins and you probably want to use some other pins for a mask anyway other than P0 and 1, that was the only thing we found. Otherwise it kind of just works. But yeah, I'm sure we can come up with some example code or something which just shows the process of loading maybe 2 of them, and then by extension, you know, to many of them.
3 and 4, right?
Yes.
Because you mentioned that you have that rotary in there to do addressing, and so I can't quite visualize how that's working and helping yet.
Okay, so that's it might be easier to show it on. This is Cluso's. This is Cluso's board, and we've got that same rotary idea is on Cluso's board there, plugged into the higher. So this is on P44 up to 47.
Okay.
And this rotary switch has got 16 positions, so 0 through to F, and it just sets, you know, P44 up to 47 to literally, you know, whatever's on the dial. So there's, I believe they're pull up. It's a pull up or pull down. Actually, the resistors are pull down, and the switch when it makes contact is a pull up switch. And all you have to do when you do the prop check or prop hex loading command, you just need to give it that mask of those bits which are on port B, and then you also need to have your kind of your matching key which matches that. So yeah, I think we've had 8 of these running concurrently, and in fact, the 8 was Brian had 8 with you know, manual sort of pull ups and pull downs, and then we've subsequently changed over to these rotary switches. And going forward, we'll probably just put one of these little rotary switch footprints on almost every board we do, just so that you've got that option of having multiple boards connected.
Busing them, right? Nice.
Yeah,
that helps.
Yeah.
So
So
it's an additional addressing set of pins that.
Yeah.
You tell the driver which pins are going to be used, or the programmer, and it understands to.
Yeah, and it's not like you can't use those pins if you know, you can make a board and still use those pins for whatever function, like here we're using for a MikroBus socket. But we've got that encoder just sitting there. If we ever need it, then okay, it might stop us from using slot 6 the way we wanted to, or it might not if it's just like an I2C module or something like that.
Sure.
But yeah, it's just worth having, you know, like that. These little encoders, I think they're about the same size as a reset button. You know, they're sort of about 7 millimeters square, I believe. Yeah, it's not much of a price, you know, for a little footprint, but it gives you that ability to load up multiple P2s. And I think, you know, once the joy of just having pins that do anything, you know, once you've got these sort of powerful P2 pins, you just want more of them.
Yeah.
But for some applications, you know, why not? And yeah, so yeah, cascading, like everything we're doing at the moment is sort of working around making sure we can cascade these and have more than one, you know, so we can just, I think there's 4 or 5 of them fit on this. This is a standard 19-inch kind of rack length, I guess. And, you know, so we can have multiple of these cascaded.
So you're just hanging a P2 off of each quad, or each hex of the micro things.
Yeah, yeah. Each one is
that makes sense.
Yeah, it's got its own local address, and then you've just got to party line up the propeller plug bus. You know, the 4 pins of the propeller plug.
Right.
Yeah, that's
sweet.
By the way, Chip, I need to correct what I was saying about seal and floor earlier. They don't go towards and away from 0. They do go, like seal goes towards positive, even for negative numbers. So negative number.
Okay.
So negative 2.1 becomes -2 for seal. For floor, negative 2.1 becomes -3. But for positive numbers, seal is
gotcha.
the next bigger number, and floor is the next smaller number. So
interesting.
That was the difference.
Wait.
So like that's the difference for floor from trunk, is that 2.1 trunk is 2, but floor is 3 for negative. Sorry, negative 2.1 is -3 for floor.
Okay. Okay, good to know. So floor rounds downward, seal rounds upwards.
Yes. And upwards meaning towards positive infinity, and and downwards means towards negative infinity.
Right, is it rounding or forming?
Right.
It's when you mean rounding, it's not a rounding operation exactly. It's the closest number that is smaller than for floor, and the closest number that is larger than for ceiling. And the larger and smaller change direction with the sign, obviously.
Yeah, so there's no rounding involved with those.
And obviously you get rid of the fractional part, you end up with an integer, with floor and seal. So it is rounded to the nearest integer, but it's rounded to the nearest integer that is less than for floor and rounded to the nearest integer that is greater than for ceiling. And
Well,
that's why,
rounding-
so like I said, negative 2.1 rounded would go to 2, negative 2, but floor goes to negative 3.
I'm questioning your use of rounding, Roy, because that implies the use of the 0.5 or some decimal distance.
Yeah, that's what I'm saying. It's not rounding in that sense, that it's not, going plus or minus 0.5. It's just going, is it closer to 2 or is it closer to 3? Like which whole number is less than this number you gave me? Is what it's saying for floor.
Right.
It is doing what trunk is doing for positive numbers for negative numbers. So
No,
the other way around.
It doesn't do the same thing as trunk at all.
No, I mean, it's the other way. So it will take the most next negative number instead of the just truncated one. Yeah. No, I'm formulating.
Well, it's like
wrong.
this.
But basically, it's the behavior of floor and ceiling is inverted on the negative numbers to the positive numbers.
It's not really inverted. It's mathematically correct.
Yeah. Okay. Good.
It's saying that this number is bigger mathematically, right?
Exactly.
Positive numbers are bigger than negative numbers. Negative numbers are smaller. That's the way it works.
Yeah, exactly.
Hey, well, Roy, take the value. Okay, take the two values, minus 2.1 and minus 2.9.
Both
Both
become
those are
minus
gonna
3.
produce the same for floor, and both become minus 2 for ceiling.
Yes.
Okay. Yeah, so it kind of absolutizes the well, it doesn't, it's sort of like
It quantizes, well, like I said, for floor, it's the largest whole integer that is less than the number you gave. And for ceiling is the largest whole integer that is greater than, or the smallest whole integer that is greater than the number you gave.
it's more like trunk than it is round.
Yes, in that sense, except that it's not trunk because it doesn't leave you with the whole number portion of
Yeah,
your
it's
float.
not absolute. It's not squeezing towards 0. It's just moving towards the next higher or next lower number.
Yeah.
The next lower or higher integer.
And a lot of people get burned by those in their code if they don't understand that correctly. They just go, I'll use floor instead of trunk, and they get the wrong numbers sometimes, and they don't understand why.
Yeah. Because trunk is sort of an absolute operation. It's almost
Trunk,
like
if you
arrowing
got
down
two
towards 0.
for trunk, 2 point whatever is 2. Like it doesn't matter what the fractional part is, it's just 2.
Right.
So truncate is take the fractional part and remove it and leave the whole part only. It's very different than floor and seal in that concept.
Yeah. Right. Okay. I'm gonna hopefully remember this. So we need floor. So we need floor and seal as. So we need floor.
Our float operation, they take a float in and return. Technically, they still return a float. It's just the float rounded to, or converted to the appropriate number.
So what it means is we have 4 different ways to convert a float to an integer. We have floor, seal, trunk, and round.
So, like I said, technically, floor and seal return a float. It's still a float. It's just round, a whole number float.
Oh, these return a float.
The only way to get from a float to an int in most other languages is to cast it.
Okay.
Like even trunk in C still returns a float. Just truncated.
But then in our case, without operators, without types, Don't we have to take advantage of the integer return to do that casting for us, Roy?
Well, the problem is then you lose the ability for you to do things like, 3.5 times floor of 6.3, because now it's a float times an int. And
well, should we have like floor and floor dot, seal and seal dot, trunk and trunk dot, round and round dot to stay?
It sounds like that's what you need to do for everything because of the fact that you're doing no type. So all your operators have to have the dot. So all your functions need to have it. I mean, obviously for things like sine and cosine, they return a float. So you would just not have non-dot version.
Right.
These four things kind of like, I could see the value of having a float, but mainly I think the application would be to get an integer out of it.
Yeah, most of the time you want an integer, but in a lot of the cases, seal and float end up being used in compound operations, and you want it to still be able to do the math. In obviously in other languages, they just cast it up, right? They implicitly cast appropriately as needed, so it doesn't matter. But for spin, since we don't have casting and you don't have types, you have to specify it with your operator or your command.
Okay.
Which I think is pretty okay for a microcontroller. I mean, you need to know if you work with floating or integers, and having different operators, I think
Hey, how are you?
Unmute yourself, Jim.
I'm not muted. I was
No,
muted.
Jim. Yeah. Jim was talking. I was trying to say. Anyway. But yeah, I think for the four things you said, trunk, float, or what was the fourth one besides trunk, seal, and floor?
Round.
I think that's it. Floor.
Oh, round.
Round. Trunk. Yeah, round, trunk, floor, and seal.
So round.
So
round. I don't foresee. I mean,
A float version.
Yeah, I don't think you need a float version of round, but I'm not. I don't know.
We could have one. Though, going to integer is pretty straightforward, but doing a floor or any of these things from float to float becomes really tricky because you've now got to worry about, like, this starts to enter into like all these exponent possibilities, right? Because it's kind of arbitrary. Like, what is a whole integer? It almost seems like we'd want to do this in an integer mode, in an integer basis, and then turn it back into a float.
So as I say, is you probably already have something that takes an integer to a float. So you could just, trunk or floor or seal to an int and then convert it back to a float for the dot ones.
Yeah. Now, okay, if we do that though, and so you go to integer as a waypoint, then go back to float. Are we going to lose dynamic range? I mean, are we not going to be able to do the full dynamic range of what we should have been able to do?
Integer can do a wider range than float for whole numbers.
Well, I mean, you can do 2 to the what, 120th or something.
It's 38. 2 to the 38th.
It's 10 to the 38th power, right?
10 to the 38th, yeah.
So, but see,
for whole numbers, integer, the difference is that a float can't represent every value at those higher ranges because the bit precision. But integers can. You only have 23 bits versus 32 bits, right? So.
All right. So we then, all right. So it's safe to go to an integer and then convert back to a float.
Well, it depends. It's not very safe, actually. It's sort of safe. The problem is that you could have a float number that's bigger than will fit in an integer as a valid float, and then going to int and back, you'll lose everything. So
Well, maybe what if we just made floor, seal, trunk, and round? Just simply they convert to integer, and if you wanted to convert that back to a float, you just put a float around that. Like you'd say float parentheses seal, and then your expression, and then right paren.
yeah, I mean, I guess, but that's going to have people are going to run into that issue where they're going to pass in a floating point number that's too big, and it's going to give them a completely incorrect result, right? You can pass in
Right.
9 billion and do floor, and you're going to get 4 billion because integers can only go up to 4 billion, right? Well, 2 billion if it's signed.
Yeah. It's just
So you may need to look up if there's a way to stay in float land to do it. like converting the number.
Yeah, well, see, it's funny because in float land, what your whole integer is does that get a little bit tricky because you're dealing with a floating point binary number, and then you want to know what's the integer portion of it. Well, is that always sensibly expressed when you get up into high exponents? I don't think it is.
I can't, but what you can do is, let's say you have 7 numbers in your floating point number. You could express them as a float, adjusting the exponent.
I think there's some correlation mathematically between the exponent and which bits of the mantissa represent the whole number versus fractional.
Yeah, I think there is. There actually
And so
is.
you ought to be able to figure out from the exponent how many bits to mask off of the mantissa down to 0 to get the whole number. And really, technically, you're not actually getting the whole number in float. You're getting the closest representation of that whole number in float, because like floats can't represent certain whole numbers. Like you can't.
See, when you get into a high exponent value, none of these things can resolve properly because you can't even know what the fraction below 1 is, because all of your mantissa bits are for maybe the LSB of the mantissa represents 64K.
Yeah. So what you would have to do is if the floating point number has a large enough magnitude, or the exponent is large enough, then there is no fractional part in the mantissa. So you don't need to do anything. It's already floored, right? Like you can't do anything to change it, like because there is no fractional part. So that's the other thing is, like when you pass in a float that has no fractional into floor and seal, you get that number back, right? You don't get the next lower one. So like negative 2.0 is still negative 2.0 after floor or seal.
Yeah.
So basically what if the exponent is large enough, then you don't do anything, you just return the number. And if the exponent is not large enough, then you mask off some number of bits of the mantissa. I bet I bet we could look up floor and seal and find a C implementation of it that does the appropriate thing.
Yeah, it's tough, this floating point thing, that the code explodes in size because of all these little corner cases.
Mm-hmm.
I mean, to cover them all, you could double the size of your code.
Oh yeah, easily. Float has a lot of stuff. That's why most people like it to be built into the chip as silicon.
Yeah.
Maybe for P3 we can license a IEEE for 754 module to plug into the chip.
Well, I think it could be designed. I don't think it'd be that hard to make.
You could design it too. I mean, if you want to, but
yeah, I think we should just look up how other I mean, I'm programming 86 assembler also, and with that SSE instructions you got 128 bits. And they don't fit into a 64-bit register either. So there are rules how they handle overflow from converting float to int, which we should kind of find in that IIE, whatever.
Well, I mean, on modern processors, you have floats that are all the way up to 128-bit size for the float, or 80-bit, or 64-bit, or even 32-bit, right? So all of them, and they have conversion between them all. So you can go down from a 128-bit float to a 32-bit float. You'll obviously lose something if it can't fit, but they have all those conversions.
You're right, and we should kind of look up how they do that, but the rules are there, and do basically the same here, because we have the same problem. We have to shrink down a floating point that it fits into an integer, sort of.
Yeah, this business about infinity, I don't understand, because you can't mathematically arrive at infinity. It's like you'd have to be able to plug in some value that says this is infinity, and then it deals with it like it's infinity. But you can't just like do any math. I mean, 1/0 would be like infinity, but there's no other way to get to infinity that from normal like this times that, or you'd have to have some express like token to say, I'm going to assign this to this float, and that's going to make it infinity. I kind of think that we just should forego the infinity business and just do not a number, because how many people really need or are going to get their heads around the implications of dealing with infinity? Because then you're like working out limit equations all the time, right?
Yeah, and then we end up with some sort of float and not IIE, whatever that is. So we can say P2 is supporting float, but not like other people do. Oh, not nice. We should kind of get same rules implemented like it is in the standard.
Yeah, I don't know if we can do like the full egghead implementation of IEEE 754.
Yeah, but at least be at reasonable close. I mean, you are right. Infinity is something, if that happens, you can say, well, it's not a number, it's out of the range, and we can.
Yeah, man can cover it.
The result is fucked up, and you have you are out of your range. I mean, yeah.
Yeah.
I'm thinking about with all those operations that this function you can do that you return kind of now two values. One value would be that as a result, and the other value would be, oh shit, we have an overflow condition. But with inside of equations, I don't think that you can handle that in any form or shape. If there is some wrong number in there, you basically have to cancel the whole operation and deliver not a number. Sorry, I'm out of my range. I guess.
Yeah.
And in most cases, it will be okay. But then you can't claim that you are I3, whatever that's called.
I'm trying to find the situations where the result is inf, and I'm not finding it right now, but I have run into it where I've done math operations and ended up with infinity results. And obviously you get NANDs, NANDs all the time. And then the other thing that can happen is you can end up with denormaled floats represented by IEEE, which is usually not that big of a deal, but it can cause issues on
Those are
some
like
processors.
Super small numbers, like approaching 0.
Yeah, well, or just a situation where the exponent is larger than it needs to be to represent the number. There's certain situations where denormaled means it's not the best representation of the number, is really what it kind of means.
0, is like the smallest exponent, which really means like -127. But then when you get down to that, you have to start placing the MSB. There's no more implied 1 in front of the mantissa. You actually put the whatever trailing digits there are into the mantissa itself.
Yeah. The other thing is, I think I recall you talking in one of the other streams about small floats. They do have what they call a float 16 or half float, which is a 1.5.10 format. Gets used a lot on GPUs with graphic stuff.
Oh yeah, that's like 3 decimal digits of resolution.
Yeah, but it's totally fine
Good
for
enough.
things like normals and light directions and things like that, which are fine to quantize to that kind of precision. So they get used all the time to pack stuff into smaller amount of space, so they don't consume all your GPU memory. Like we on our meshes, we'll pack the normals into 2 F16s because you can recalculate the Z from the XY of a normal. So you pack it down to 2 F16s instead of 3 F32s, right?
Right.
And stuff like that. In fact, actually, for normals, we pack it down to 2 8-bit values because they don't need to have the precision at all. And normals are always 0 to 1. They're not, so you have 8 bits of fractional precision.
I wonder how that would work for audio, if it would sound poor, or would it be okay?
I guess it would just depend on how you scaled your audio, like, because 10 bits of precision, which is what you would have with a 16-bit float, is plenty for audio, as long as the range of your numbers is like between 0 and 3 or -3 and 3, right? Then you have,
Yeah, we have a 5-bit exponent too, so
yeah, so you can get up to like 60K with no fractional if you want. But we mostly use them for numbers that are very close to plus and minus 1, right?
Right.
Maybe as far as plus and minus 10. You start using larger than 10 and your fractional precision starts becoming noticeable visually.
Yeah. I'm glad we talked about this floor seal trunking around. I didn't know that C just returns floats for these. I thought these were always just like integer, float to integer conversions.
Well,
but
because C is typed, it knows it can compile appropriately,
yeah,
right? And it does
right.
implicit upcasting. So like if there's a float in the operation, basically everything gets turned into a float and then it does all the operations.
Right.
It gets upcasted implicitly. Which can be interesting if you're expecting float results and you include a double in C. Double is the 64-bit float. It will upcast your floats to doubles, do the math, and then downcast them back to float for the result. And doing that, you can end up with slightly different results than if that double was a float instead.
Right. Man.
Double can represent numbers that float can't, right? 32-bit IEEE versus 64-bit. 64-bit can represent more of the individual numbers along the way. It's not as quantized.
Yeah. Yeah, adding float to this is going to it's going to affect a lot of things. Like we're going to have FLE, force less than or equal, force greater than or equal. We're going to need like float versions of those, everything that, and it's also going to expand the like compile time math setup. A lot of implications. It might be kind of a big thing to finish.
Yeah.
Is there much impact on the you've got like, is it 130? I can't remember if it's 130 decimal or 130 hex bytes free in the cog, for doing inline assembler. Does that get eaten into by the floating point
Oh,
code? Is that mostly sitting out in hub or?
I have a set of a byte codes that you give a certain byte code and then you give it another one and then it goes out and does an index into a word table of an address in hub memory. So
Okay.
this stuff's not going to impinge on that space. It's all going to wind up being these special byte codes that go out to hub.
Me and Jeff talked about that specific idea, that concept, like several years ago when it was still P2 hot, the old one. We're talking about implementing Spin 2 with that kind of thing where people could write functions that extended Spin by having a bytecode that would call their hub function, right? And it's almost the same thing that you're talking about. And so like you could add built-in keywords for things like I2C and SPI in Spin 2 in hub memory via that mechanism. And it would
the
be
tricky part
almost
though,
free.
is getting the parser to do its job becomes the hard part. Because now,
for I2C and SPI, it's just a handful of commands that would just immediately parse into a bytecode that called the right thing, right?
yeah, but there's got to be rules for every instruction. I mean, if you can make it into kind of a table thing where it's like you have some bits to say, how many arguments are there? How many return values are there? Where do you call, or what's the code number for when this happens? Then it could handle it that way. You know, kind of genericize.
I'm sorry. I didn't mean to say that you should implement the thing that me and Jeff talked about where users could add their own thing. I was just saying that you could add to Spin 2 I2C and SPI commands that are just built in that do the right thing. Without needing to include a library, and it would just add it to hub memory when they use those commands, right?
We could do that, but I mean, it may also be possible to add into the compiler some kind of setup where you can say, I want, when you see this keyword, this is a function or a method, right? And it's going to have this many parameters, and it's going to have this many return values, and it's going to equate to like hub bytecode X. So that way the compiler could actually parse it, you know, and then generate the code, and then your assembly code then would deal with it.
Yeah. But anyway, don't do that yet.
No, it's too much.
We need other things to do first.
This floating point's like an expanding headache. The more, I just when I think I got a handle on it, I realize it's more complicated than I thought it was.
Yeah, floating point is kind of a complicated beast.
Yeah.
But it's also super valuable. It's super useful.
Yeah.
The fact that you don't have it is a hindrance for a lot of people using Spin, in my opinion.
Right. I understand that.
It's just like you know, not having a integer multiply instruction is a huge difference on a microcontroller.
Right.
Anyway, thanks, Lachlan, for going over that stuff again for me, even though you already probably went over all of it earlier.
Oh, it's no problem. It's not a complicated board, so it doesn't take long to, you know.
Yeah, exactly. What else is new? I've been missing a lot of these because of work. Implementing floating point in Spin 2. Lachlan and Brian are producing boards at the rate of 1 a day or something like that. New designs.
We just did it. We did this batch. I think during May we sent off about 30 or 40 boards, and so we just, you know, because it's getting hard to do them in single files, so we thought, okay, well, let's just do one big batch with a lot of the ideas we've been talking about, and get them made. And you know, there's a few boards. Roger, I think you probably saw Roger's got some memory boards, and you know, we're probably put another batch in this weekend. which will be kind of updates from what we've been working on. So we've got these designs coming through in parallel. And there's some products we're aware of which are kind of in the pipeline from other companies that'll probably suit, being used with the P2 as well. So we're just trying to keep things ticking along and developing so we can, we're sort of doing this for our own use mostly, but some of these will have fine generic use as well. So
Cool.
yeah. Did you see the little tiny, like the dime size board from last week, 2 weeks
yeah,
ago?
I saw the picture of that, and I was able to watch some of that from YouTube.
Yeah.
I was at work and I just had it on, but I couldn't interact. So I saw some of that. That was really cool, tiny little board.
Yeah, it's that's going to be we're going to find probably quite a few uses, because the smaller the board is, the more you can use it in some ways. You can fit it into tighter applications. The other thing, I'm just waiting. We're still waiting on all the stackable connectors. Like those stacking connectors aren't really well stocked, and so we're waiting for those to come in. I think tomorrow, maybe. One thing that's interesting about that, which I didn't really tweak to initially, but you can stack, like when you stack them, the stack height is 2.6 millimeters, or basically 0.1 of an inch. And so we might actually be able to, to kind of be able to just stack modules and connect things on at a rate of 0.1 inch. It'd be a super dense kind of stacking mechanism. So.
The only thing I'd worry about there is heat and interference between the stacked boards.
Yeah, you've got these two, because you've got these threaded spaces, like 1 millimeter threaded spaces running through the whole stack, and then you've got some steel screws which also tie everything together, and so you've kind of got those columns of metal which you can use as if you want to, like to spread out the heat. Whether it's done with some aluminum or copper or a circuit board based sort of heat spreader, you've got that option to get the heat away. So, and there's this fabulous product which used to be made by Bergquist, who got acquired by someone, but it's like a sort of a silicon blanket. You can apply it to things and it just kind of soaks up the heat and spreads it around. So thermally conductive blanket, and I think they used it for. Well, I guess you can use it for things, but it compresses down, so it absorbs a gap. If you've got a gap between your circuitry and a heatsink or a case or something like that, it sort of solves that problem where you've got a variable height and you just want to compress it against there. So it's like a big thermally conductive doona or blanket, and I think that's how they used to market it.
Sounds interesting. I've not seen that kind of thing. That's cool.
Yeah, it's like I think you see with heat sinks on things like the Raspberry Pi, they have like a double-sided thermal tape.
Yeah, no, I've seen that.
Yeah, so it's a similar kind of material. It's like a sort of a foamy kind of silicon, which transfers the heat through. So.
Oh, maybe that's what they use on those the new NVMe M.2 SSDs. When they have them with a heat spreader on them, they'll have this material. It's like you're describing, like this little pad that's between the chips and the thermal, the heat spreader, and it's not glued in. It's just compressed between the chips and the heat spreader. So I assume that's conducting the chips up to the heat spreader, and that material is what you're talking about.
Yeah, I just found a link. I'll post it into the.
Okay.
Well, it's it kind of takes up, or it absorbs whatever the gap is, and it doesn't have to be a uniform gap. So if we need to, that's our kind of backup plan. If we're not getting enough heat transfer around.
Yeah, that's why they use them on the SSD, those little SSD cards, because the controller chip and the flash chips are not always the same thickness package. So the pad makes up the difference in the fact that they're slightly different thicknesses.
Mm-hmm. Yeah.
Hey, Chip, What's the status on the P2 Edge with RAM?
I was just asking Ken to get on and explain, because he's got Michael Mulhall and, Von Sarvash busy with some stuff for some educational things. And so I'm not really sure. And I've been kind of out of the loop for like a week or so. So I'm not sure what the status is, but I know it's like imminent. We've got the normal P2 Edge done with the new power supply. This other one just has those 4 little chips. And it's funny, I was just looking on my desk. Where'd I put them?
Oh, so we got the new Edge version with the power able to handle up to what, 20 volts or whatever it was.
Right. And I've got the parts here in this bag on my desk. I was worried I had lost it, but that's for the 2x3mm 8 megabyte SRAMs. So
Okay.
he just has to do the layout, and it's really not that big of a job. I don't think it'd take him more than a day or two, because he's just, taking some wires that normally go down to the connector and disconnecting them from that and routing them up to those chips. In fact, here is, let's see here.
So on the RAM version of it, are the pins that go to the RAM not going to be going out to the Edge connector?
That's right. Yeah, because they can't suffer the loading. Who knows what would happen?
Okay. Yeah, that makes sense, I guess.
And here, let me pull up. I don't know if you've seen it lately. Let me.
Yeah, but in my opinion, Michael said end of July because of delivering problems with the boards. It takes longer. The lead time is longer, so they don't have the boards. So July is the name.
Yeah.
Well, you're probably also having issues just getting some of the components right now too.
We might be. I'm not sure.
Definitely for some of the chips, I would guess.
Yeah. Yeah. Can you see
Yeah,
that?
I saw this picture on one of Ken's emails, I think, about one of these shows.
Yeah. So. All right. I'll quit sharing that.
And the RAMs are on the back side of that board, right? Or no, they're little tiny. I forgot they were just little tiny chips that I didn't realize they were RAMs.
Let's
No. Last post was that they are able to fit them on the front
Yeah, because they're little itty bitty ones.
Yeah. 1, 2, 3, 4, and each of those is 8 megabytes.
Are they BGAs or are they
they're like
QFNs?
Yeah, they're kind of like QFNs. They're 2x3mm each.
Yeah, so the pins are around the edge, but they're underneath, like
you can
the
kind of
QFN.
see them hanging out the bottom here.
Okay, yeah. It only have pins on like the top and bottom of each, and not on the sides.
There's 4 across the top, 4 across the bottom, and then there's like a little tiny sliver across the middle, which is ground. So it's like an SO8, but just reformatted to be real small.
Yeah, I get it. And the SD card connector is also really nice.
Yeah, that'll be kind of permanent. That'll be on.
Actually, it's kind of according to the posts optional, so you have to solder it by yourself.
No, we're gonna solder it on. It's on the BOM, so it'll be on every board.
Okay, I like that one.
They're really handy for booting from SD. You just plug it right into the card.
Yeah.
Right.
And obviously it's handy even if it's not on the card, but it's you don't have to add one to your board. It's just right on the edge card.
Mm-hmm.
Right. And it's going to stick out the top by a bit. But that makes it easy to get to.
Yeah, well, that makes it so that if you build a case around this, the SD card can stick out the side of the case.
Nice.
Right, right. Yeah, and there are no components on the back. It's just flat.
But that's where you would want to put cooling if you had it. You would like
Yeah,
put
it's a nice
something on the
contiguous-
bottom.
Yeah, it's a really big contiguous ground plane. In fact, let's see. I think. Yeah, here's what the back looks like.
Is this a 4-layer board?
I think it's 6,
Yeah,
isn't
it's a
it?
4-layer board.
It's only 4.
Yeah,
Okay.
they
It
went
used to be
down from
6. The one.
yeah, they went down from 6 to 4. Yeah,
That's good. That makes it a little bit cheaper for you guys to make.
yeah, and
Yeah,
more
and-
distance
and
between
it-
the layers. Cool.
The main
yeah.
advantage of having only 4 layers, it made you think about not passing signals under in the internal layers, high frequency signals into internal layers, where they are very hard to calculate all the interferences from the both layers that surround those signals. It's easier to calculate the signals at the top and the bottom layer, but the signals that run into the internal layers are a lot harder to calculate how they get influenced by the nearby other signals.
Yeah, especially if depending on where they put power and ground in those layers. Like, I don't know what the typical arrangement is, but like if you have signal, power, signal, ground, power, signal, right? You know, it depends on the order. You could end up with some weird calculations to figure out the interferences and stuff.
Yes, yes. As soon as you are tempted to use the 6-layer boards, you are likely to be forced to go to 8 or 10 because you get in so many trouble with the signal interferences that you are you need to use other layers to get your signals. But if you don't have any options, okay, that is a valid tentative. But if you can do it in 4, it's better. Not only by the price, but for the whole understanding of the board.
Yeah, yeah. It
Yeah,
makes me
Michael said he was able to reduce it to 4 layers. Also because of that oscillator thing. Because with 4 layers, they have more distance between the layers, as far as I understood.
Right. 1 and 2 are close. 3 and 4 are close, like 2 mils apart. But then there's a big sandwich between those two.
Yes. Yeah. That is
it makes me boggle at how motherboard manufacturers can make these 8, 10, and 12-layer boards and sell them for peanuts almost, right? You can buy these super complicated motherboards for a computer for $100. It's like 8-layer, 10-layer board with. It's like, how do they make them that cheap?
Your cell phone probably has 12 at least, and more likely to be 16 layers.
Yeah.
But,
well, I was just talking about computer motherboards. Yeah, cell phones are even worse.
yeah.
Tablets and cell phones have, because they're trying to make so much room for the battery, that they make the boards so dense with chips that they have to put a million layers on them because they don't have anywhere to put the traces on the top or bottom of the board because of all the components.
Right.
You literally have a row of chips on a tiny little sliver of board, and you're like, where's all the traces? It's all inside.
Yeah.
There is a technique you can use even by leveraging from the 2 layers only versions of free software. If you don't complicate a lot the ground and VCC or VDD planes, you can do into 2 stages by having 2 boards with the same or the same shape, and you can use the 4 generated masks to create your board. You don't need the auto router to place all the connections. You can get to the vias when you have a VCC or VDD or ground, and then you join the four masks and form your board only leveraging from 2 layers available of free software, like Deep Trace.
Yeah, basically that
It's
is
not that hard to achieve.
That is what from Sarwas or whatever Michael explained, that basically they have two layers and they are distanced more from, so the central fabric, whatever is in there, is separating two layer boards basically to get the signal cleaner. That was what he told in the last one of the last forum thingies. So I'm looking forward for it, honestly.
Yes, those boards are nice.
Mhm.
Von Zarva's board are very nice.
Yes.
There are many others too. There are guys. There are a new guy in the forum trying to make a board to.
Yeah, for the rocket. Yeah, that's for the rocket. Yeah, for the rocket.
Yeah.
I looked at it too. Yeah, it's nice. A rocket with a P2 or a rocket controller, basically.
Yeah.
That's a nice board.
Let's see what it gets.
Yeah, I'm honestly have to nag Chip about. I mean, I personally don't really need floats. I can work with scaled integers, but that motor controller board, honestly, what you wrote at software there. Sadly, I wasn't at that. It's just half of it on YouTube. I was on the meeting, but half of the meeting is cut off because the recording stopped. So you should please do another YouTube about your motor controller and the idea of sensing behind, but all of that is missing in the YouTube video pushed out because it stopped when we switched to whatever. Ken had to leave and we switched to Steven, and then the recording stopped. So on YouTube there is nothing of the last 2 hours where you explained basically that motor controller and how you the basic idea of sensing with the motor wires instead of having how, and all of that is missing in the YouTube video. Would be nice if you do another one about the motor controller.
Well, let's see. I didn't know it got cut up. I'm looking at my email right now. Trying to find the latest. Let's see. Here we go. Let me pull up the schematic real quick.
No, I mean, you made that presentation and you explained a lot of it in it, but half of the presentation is missing in YouTube. I was there, I listened to it, I wanted to play from a friend, but the last 2 hours are missing because then Ken had to do something else and Steven, I think, took it over, Steven Morocco, whatever.
Well, what we'll probably wind up doing is when we get this new motor board, and I think I went over, last time we had one of these meetings, I think I shared the schematic and went over it. Pretty straightforward. But Michael should be finishing this board I think that this is the next thing he's going to finish. And
Yeah, it's a nice idea. I really looking forward about what you, I mean, you showed that with debug window lines, you know, current consumption, the waveforms running through the three. All of this is missing in the YouTube.
yeah, so what I'll do is when we get this new board, I'll just do another presentation. And
Yeah,
it'll be
please.
more, it'll be better in the sense that anybody can buy the board.
Mhm.
Plug it into a P2. So it'll have more applicability for people watching the video.
No, it's a nice design. I mean, I'm earning money currently with building motor controllers for electric vehicle stuff, old ones, you know, things which is done 20 years ago. And I really like your design, except that I need way more bigger fets. But but basically, what you are doing there is cool.
Yeah.
You know, it's absolutely cool. And it's energy efficient. I mean, if you can get it at the right angle, you save battery power. And I mean, come on, I'm not happy
Yeah,
about
that's what the
current
Hall
state.
effect.
Yeah. No, that's honestly a nice board, and I'm looking forward to trying it out. You know, waiting for that too. But your debug windows you showed, you know, I love it. Does exactly what it should do, you know. Even all without Hall sensors, it can learn. Then we have a couple of Corbins running with them. My Corbin three-wheelers, I don't know, a couple of them currently. Yeah. Actually, I mean, I can
I
even
look
throw
forward
a
to
name. I can even throw a name in here. Was dear Steve Jobs comes once a year down to Clear Lake to get his three-wheeler fixed. I haven't met him yet, but he is due in the next 2 months. He is due to come down here and get the wheeler checked. He is coming once a year, and I'm just working there since half a year, so I haven't met him yet. And it's a fully electric three-wheeler.
I heard something back from Ken. He said that, well, yeah, this, you know, Michael, this, I think by putting bigger FETs on this thing, you could probably get to where you need to be. I don't know how much extra protection stuff you'd really need.
Yeah, I mean,
this is enough to like be able to try out any idea, any, you know, prove any motor control concept, and then you can scale it up if you need to.
You said you're running something like 40 amps at 40 volts. That's not
40 volts, 25
that's
amps.
not nearly. I mean, it's for Europe business perfectly nice, but I have to run those things at around 360 volts. But I mean, that's not a problem, you know. I have those not FETs. They're called different G, whatever, have a different name. The main point is the software that you kind of and the P2 as a module on it, you know, and I can, I don't know, just feed the other GBT, whatever they're called. I can't remember the name right now. I can feed them with those FETs on the board. They need a little bit more than 10 volts to switch fast. But basically, I mean, I can just put an add-on board on it and I'm fine. The main point is the software you wrote, and I like that whole idea of being able to sense the not active wires to get the position. without a house.
Yes.
You know, that is honestly a completely interesting thing, because if you can optimize that, you basically hit the motor wiring at exactly the point where you need it to hit. So you are most energy efficient, and that is for important for those electrical vehicles. You have a lot of loss with those bullshit, you know. Yeah, and that's why I'm looking very, very, very carefully of doing that.
Well, on your setup, do you have Hall effect sensors? Because it seems to me that takes a lot of the guesswork and uncertainty out of driving a motor. If you have the Hall effect sensor, you can always
currently we have sensors on those, but we have two. Oh, shit. We have two another stupid one company wants us to replace the diesel engine in their those trucks which pull cars off the road. Kind of rescue truck, whatever you call it. They are just running 2, 3, 4, 5 hours, and they want to have them electric. And another company wants to have a bulldozer replaced. And those guys, I mean, we are talking about a lot of voltage and a lot of amps.
Electric bulldozer?
Electric bulldozer, yeah. They will bring the bulldozer over here. They remove the engine, bring the bulldozer over here next week. And we have 4 weeks to put some engine in, and I'm working on it.
Wow.
An electric bull, but that one is just supposed to work about 2 hours in a row, and then it can sit again. It's not supposed. It's just for they are producing stone and here gravel, and they just need to load a couple of trucks, and they want to. Give us the old. They bought a new one and they give us the old one, and we should make an electric one out of it. Yeah, but
Wow.
those 40 volts will not do it, you know. But the whole software, I mean, and with those 40 volts, I can drive everything. I mean, I put stuff another power stage behind, and then I can run whatever amps. But the software you wrote, that is a point where I'm really, really, really lusting for, because that can make a huge
Well,
difference.
it wasn't much. I think it was just a couple of lines of code within a repeat block.
It wasn't much,
that-
no, but
that
you
did the
can do
motor
it with a
control.
P2. You can.
But that doesn't. It didn't have any like absolute position tracking. That was the next thing I need to add.
Yeah, but
And
basically
something to integrate position and then know what your absolute.
Basically, you have on the board those shunt registers where you can measure the current running. So you basically, it's just a software thing to figure out where you are and when to pulse, you know. I mean, it's, in my opinion, it's kind of just the hardware is there, and P2 can measure it, you know. That's a funny thing. You can power the line and measure it. I mean, yeah. I'm pretty sure you can make a lot of nice applications for that motor controller system sort. And another thing is motion controller. We have 1 year with putting G code out now with GRBL. There's a post in the forum. Somebody was able to port one of the most open source used G code interpreter thing to the P2, and it's running nicely. You have to look for that post. There's a small demonstration, kind of a small calculation. Yeah, going for
The high side, low side 8-pin chip that we're using has an integrated diode, but the first one that Doug Pintack made here that I have on my desk, it has an a discrete diode you have to add to get the charge pump for the high side switch.
Yeah.
But that thing is good for up to like 600 volts.
Oh, nice.
So
Specs was 40 volts with I don't know 25 for all 4 of them or something.
well, see, on our latest motor board, we went to a chip that had the diode integrated, but it's
Yeah.
only good for like 85 volts. But the other one we had where you put the discrete diode in, it was good for 600.
Oh, cool. That would be nice. That would be enough for the carbines. They are running up
And
on
that's what you need.
220 to 280 and 480, depending on the year they were built. So the electrical three-wheelers, you know, I showed you that with a Harley motor, but there's the same thing with an electrical motor. They were built until 2004 or something, and we took over that company. Oh. But 600 volts, 600 volts and 25 amps are still not enough. Yeah, but still, I can use that thing to kind of power a second power stage and use the same software. I love it. Please. I have a lot of wishes for you, I know, but this thing is honestly important, and yeah.
Good.
Yeah, Enrique?
By going to 600 volts, doesn't you need to place some cuts into the board to avoid arcing?
Oh, sure. Yeah, I bet. Yeah, you'd have to
Oh.
design the board a little bit differently.
Yes, yes. And you have to be nice with the inductions because they will cause a lot of trouble.
Yeah.
Any energy stored in such a high voltage will be returned back twice, at least. The part you can see at the scope is just a small part of the back arcing.
Right.
Yeah, Enrique, when you run 400 volts, or you don't have board traces anymore. You have copper bars mounted on the board, because I mean a car, even small. I mean you are talking about 600, 400, 500 volts and 20 years, 30 years amperes, even more on one line on the board, and you parallel them anyways. So you need really copper bars on. You don't use trace. I mean, you have traces, but basically you have copper bars on top of the traces to handle the heat and current.
Yes, I saw many boards from the 60s where IBM used copper bars over the traces.
Yeah, exactly. That is what I'm
the available current.
Yeah, that is what I'm doing also with our boards. We simply have copper bars kind of on top of the traces to get the load of the trace. I mean, we do have traces to test it, but basically the load goes over the copper. It doesn't last. It doesn't last if you don't do that.
Every failure is catastrophic at those levels.
Yeah. And it's cheap. I mean, it's like a pencil. It's a small copper stripe, but it's kind of can take. It doesn't glow. Yeah, but I'm really looking forward, Chip, please, on software for your proposed motor controller, because I think that might be a very nice product. Yeah.
Oh, right. I had a question about the the motor controller? Because I believe the hub motors that you guys are getting are just 3-phase motors, right?
They are, well, they're brushless DC motors. Yeah, they have 3 wires that control.
Yeah, they're
them.
3-phase brushless DC. But you were talking about your board is going to be 4-phase.
Yeah, we have. So you could run like 2.
You cut off.
DC
You cut
motors.
off, Chip. I didn't hear what you said. You just
Oh.
said we have. It went dead, and then you came back.
Yeah, we have 4 half bridges. So you could run like 2 brush DC motors independently. Or you could run, for steppers, you might need 4 volts. It's just kind of, the point of the board is that you can do just about any kind of motor control with it.
Okay, so it's 2 regular motors or 1 stepper or 1 3-phase.
Right.
In the 3-phase, you're just not using one of the H bridges.
That's right.
Cool. It'd be nice to have a 3-phase motor driver.
Yeah, and what I find interesting is that you basically switch both sides. I mean, you switch the high side and the low side, which is kind of interesting in my opinion, because a lot of controllers I'm using, they are just switching the high side and leaving the rest connected to ground, sort of, you know. And that one, I think it's pretty nice.
Yeah, you can switch any of the 4 legs to positive power or ground.
Exactly, yeah. And that makes it pretty nice, yeah.
And you can, of course, PWM it. And there's a shunt resistor for measuring overall current on the bottom leg. And then each of the 4 wires goes through a voltage divider, so you could do an A to D on each of those.
So you have one shunt register on the bottom to catch all of them, and then you basically can kind of use ADC to catch individual ones.
Each. Yeah.
Cool.
I think it does like everything that you need to do in order to be able to control something. And so you can write the software to do whatever you want, but the hardware is there that should cover all the bases.
Yeah, I had my friend over here because I'm working with Peter, and he looked at the documentation in YouTube, but then the other 2 hours were missing. So he just got the beginning of explaining of Euro, and then it was off, you know. But he is also very impressed by the basic concept too. It's a nice board, you know. You can drive anything with it. You know? Yeah.
Yeah, it should cover the bases and give you enough power to run like pretty decent sized motors.
Come on, it's 1 kilowatt. Currently, it's about 1 kilowatt. I mean, that's a lot of power for hobby models.
That's over a horsepower, right?
Yeah, it's about 1.4 horsepower or something. For a hoverboard, it's pretty heavy, I think.
You know, it just occurred to me. You could build like these motors are super torquey and fast. You could build like a heck of a weed eater. If you had, because I got this machine down the road here. This is called a DR trimmer, and it has like 0.17 inch diameter line, right? And it has this metal head that you just push the line into, and then it hangs out. And there's 4 of them. So when that thing gets going, it'll cut down anything. Imagine 4 things, you know, this wide whipping around at like 10,000 RPM or more. The trouble is, we took it over to Doug's house because he wanted to cut like a fire break behind his house. And so we're cutting through all these tall weeds, and the little particulate that, you know, from everything getting chopped up got sucked down onto the top of the motor where it has like the screen that with the impeller that cools the motor.
Yeah.
So the motor got too hot and it just lost compression. It died, just completely lost compression. So I took it back to the shop and the guy explained that they have a plastic cam in the motor. The engine has a plastic cam in it. So it just melted. And he said it's going to cost $200 to fix. And I don't even know if I haven't heard back from him. I don't even know if I want to go that route because pretty soon I'm going to have like an $800 trimmer, you know. But it was $400 to buy. But I wanted to mount it on the front of the quad.
You have to build one, Chip. Come on, get back to the basic. We have to start. You have to dig out all those plans for that Quad Rover and replace the Honda engine by some electric motor and your motor controller. And build a Quad Rover with four of those wheels. Here, those, but you have those hovercraft wheels. A Quad Rover with 4 of those wheels and 1,000 watts, whatever controller. I think honestly that would be a nice platform.
Well, what I wanted to do was take that, I got that DR trimmer and I don't want to just push it around and cut weeds. I wanted to mount it onto the front of the quad, right? So like a jet fighter, I can like fly through the orchard and sometimes there'll be fallen leaves that stand up real tall. So you just turn that thing on and drive right into the weeds and cut them down. Because we get these poke weeds and things. But I'm thinking that if I took that head that you poke the lines into, which is really the genius part of the whole machine, because it makes it easy to reload the line. If I just got a big brushless motor,
and then you take one of those wheels and attach it to it.
The much lighter.
4 wheels to drive it and 1 wheel to run the wire.
But you know, you can, if it mounts to the front of the quad, you can drive it. You can get to where you need to go really quick, a lot faster than a robot could. And you could take out those big auto weeds.
Okay. So you will just be built and
anyway, I think a brushless DC motor.
Yeah, that can do speeds. With nice wires on it, it will hit anything. Yeah.
Have like one of these batteries like you have, and then just attempt a momentary on button. And when you hit that on button, it revs up and turns on. So you just cruise towards the weed, hit the button, and drive right into it. It'll cut it down.
And you use your ATV for it to remember. Yeah. You have a lot of noise here. I don't know what it is.
It's Ken. He's making a lot of noise and we can't understand or hear him.
Oh,
Ken is echoing back.
I'm gonna mute him. He needs to be muted this time. There.
Yeah, you mute him. Yeah, you are the boss. Come on.
Is he trying to listen while he's in his car or something?
Maybe, yeah.
Yeah, it sounded like car. There were car noises. Yeah. No, but honestly, that Quad Rover, the last time you built it, it was way too expensive to do it. You know, $3,000 something. I mean, it wasn't really a product. You know. But it was a cool idea in my opinion.
We need a quad.
With those four Quad Rover, those Outrunner, however you call them.
We need a Quad Rover with those hub motors.
Yeah, with those
electric.
Exactly.
Use LiPo batteries instead of gas.
Yeah, and I provide LiPo batteries here.
But the same, big tires and the aluminum frame and everything, but just use those hub motors and
lithium. I'm the guy I'm working with. He is getting all those crushed Nissan Leafs and dismantled the batteries. And so we have tons of those. Tons of. There are blocks like all of you are old enough to understand what a long playing record is, and those batteries
LP.
are basically size of a long plate record and 2 inches high, and they can be stacked. And that
Later, Stephen.
I currently have about 400, 500, 600 of those because we are getting all those little and we dismantle them and then sell them batteries for solar systems and stuff like that. So I have lots of them sitting around here. Lithium-ion Nissan Leaf. And if you put a stack of 3 of them in one of those rovers, that thing has power. We honestly should revive that rover with those four wheels. Probably a good product.
What would be really cool is to have those hub motors with with Mecanum wheels attached to them, so that you could drive in any direction.
Oh, you beat me, Roy. You beat me. Mecanum wheels. Parallax has to produce Mecanum wheels for it. Yes, that would be a hammer.
Let's see if Ken can comment. Because can you hear us, Ken? Are you listening?
Hmm?
I have you muted right now. He's probably in his car.
Yep, I'm here.
So what do you want him to say, Chip?
Michael has this idea. You know the Quad Rover that we built that was gas powered?
I was saying that before too. Make it electric with the hub motors.
Yeah.
Yeah, that would simplify the heck out of it.
Yeah, and then I said, okay, and then make a version where you put Mecanum wheels on those hub motors so that you can run the Quad Rover with Mecanum movement. That would be awesome.
It would be awesome, yes.
Really big ones with, so it could go off road and stuff. Like. Really
yeah, but if you basically replace the rubber on them wheels with kind of mechanical wheel setup, it should be big enough. I mean, they are pretty good sized wheels right now. If you could put some Mecanum wheel ring around it instead of the rubber, I mean.
And the key thing is that the little wheels that make up the Mecanum wheel around it need to be rubber and not hard plastic.
Right. Yeah.
So that they grip correctly.
Yeah. Yeah, I tried to print mechanical wheels by myself, and I basically failed. They don't really that 3D print for the wheel for those rolls. It's fucked up. You can do.
Yeah, the little rollers really need to be. They need to be hard rubber.
They need
Can't
to
be
hard
plastic
rubber.
or anything slick.
There's a company who was selling forklifts using 3D. Using those.
Oh yeah, that's where they first appeared. Was a forklift for Mecanum with Mecanum. They still make them. That's
So it's
being used for.
It's possible to get those things hold. I mean, yeah. I never did. I tried 3D print them and I failed.
You can't 3D print those.
Yeah, they didn't. Didn't work.
I have a bunch of different Mecanum wheel sets from different companies. Actobotics made a set that's really big and beefy that I like.
Yeah.
Or not Actobotics, but Servo City sold a set that was compatible with their Actobotics stuff.
Yeah, but the problem with what Parallax now has is those outrunner motors here, those whatever. Basically, we can remove the rubber and then we have to put something else on it.
Yeah.
So
you can make a
challenge.
Well, no, you could just make a bracket and attach a Mecanum wheel to the side of it. It'll still work.
Yeah, okay. No, I honestly want to have a
Chip looks bored though.
I like.
Stop talking about Mecanum wheels. Let's talk about something else.
All right, I'm with you there. And I think it would be a very nice combination. Yeah. But even just the Quad Rover with those 4 wheels, I like the old one. Electrical driven without all the hydraulic. I mean, it can be way much cheaper.
Way quieter,
Yeah.
cheaper, and simpler, and doesn't require gas or oil.
Yeah, and you know, I mean, nice
I'll be
battery.
right back.
4 of those motors, and probably kind of some remote control thing. We are working on that here. I mean, John already did kind of that S-Bus thing for P2. Basically, all the parts are there. It's just to build them again. And I think it was one of the nicest.
It was nice, but it was really expensive, and Parallax probably lost money on it because they didn't sell them all.
Probably they did. Yeah, probably they did. And
then would have to answer
last
that.
ones here, Publishing was tasked with kind of getting the last ones out, and I was looking at my wallet and I said I want one, but I couldn't afford it. Too much. But I think with 4 of those motors, might be. Yeah. Might be an interesting thing. Ken, are you listening? No, Ken is not listening. Everybody is tired now. Chip is gone. No, Chip is back.
I was trying to find, I went into the, where Doug has his machine tools and tried to find the prototype for the motor mount for the hub wheel. He designed a really nice thing that grabs the shaft, and then on the flat side has a piece that bolts on to really lock it down in place. So you get a lot of surface contact and a lot of clamping. And then
Ken posted a picture on somewhere in the forum with that motor mount. It's smaller than the motor mount you had for the old wheel kit, but looks pretty nice, solid.
Yeah, it's a lot better designed.
Mm-hmm.
It grabs the axle much better than the other one did.
Mm-hmm.
But anyway, just 4 of those on a platform, and you have a Quad Rover.
Yeah. And you have to drive to make the software for that motor driver thingy board. We need 2 of them for a Quad Rover.
Yeah.
2 edges, and they have to communicate with each other. They have to figure something out about that also.
It would need 4 of those motor controllers because it's 3-phase, so you only get 1 motor per controller.
4 of them. Not it's even worse. No, that thing is getting expensive again. 4 edges.
Does it need 4 edges? Doesn't it just need 1 edge with 4 motor controllers?
Right.
Yeah, but the motor controller is currently designed that you plug in an edge. So you need 4 edges for each motor and another one to control.
You just make an interface between the 4 controllers, because I mean it doesn't need the edge to plug in.
You only need 3, right? Because you need 3 of those motor controller boards, because that's going to give you 12. But you're not
as long as you have control over all of them from one P2.
Yeah. You know, for handling lots of motors, there might be some need to multiplex something or other in order to save pins, because just to control like a 1-3-phase motor, you have a low and a high for control pin for all 3 half bridges, right? That's 6 pins right there. Then you've got 3 pins more for the
Current measurement.
well, yeah, that would take some more, but if you don't do the current measurement, I think you kind of need to do the current measurement. Well, you could just do the low side measurement. Because remember, you have a Hall effect sensor, which takes 3 other pins. So that's 9 and then 10. So 10 pins would control one motor without the EMF feedback, but with the Hall effect, which is the most important thing. So you could have the Hall effect, the overall current sensor, which is critical, and then you have the 6 pins for the motor, you know, the high-low switches. But that could be consolidated somehow. You know, there's not all states are in use ever. There's only a limited number of states. That could be decoded from probably like 3 or 4 pins. You know, you don't need 6 to do that. Anyway, if you could keep consolidating, you could make a much more efficient controller. Maybe we'll make that someday. Maybe.
Yeah, but first get that thing out like it is, and it's a nice design.
Yeah, this is the generic one.
Yeah, it's a nice design what you have, because you can run basically any motor you find.
Right.
And if we just want to build a controller for those Hoover wheel thing, we could kind of design it different. Not me, but somebody else out here is probably able to do that. And just run 4 motors for one. I mean, it should be possible. But that motor controller you are currently building is kind of able to hit any motor you can possibly attach to it.
Yeah.
As far as I can see, and that is a very nice product, and we shouldn't change anything on that. Just get it out so they can try it. Yeah.
Does anyone know about, you know, there are these brushless DC motors, but there are also linear motors available, right? Which use the same principle.
Yeah.
Just slide. Are they kind of like expensive and hard to spec? Or are they affordable?
I believe the German guy pick something did use it to make voice coil grade motors.
Yeah, I read that forum post.
Very high current voice coil grade motors.
Yes, yeah. Pick something. He is
Pick 33, right?
Yeah.
No, it's a number.
Who did that Hive thing? The 3 P1s in one system. The Hive. It's the same guy. He is a German too. And he is now venturing into the P2. He did that Hive thing, which were three P1s working together and simulating a computer, basically. I mean, being a computer, a complete one. I mean, with all the bullshit you can think about. and now he is venturing in the P2. Pick something number. And he doesn't speak English. So everything he sends is kind of translated from German to English, and he has to translate it back. So it's not easy for him to follow things. But he is honestly, I think he is a very cool guy. What he is doing is pretty impressive.
PIC 18 F2550, which is that,
Yeah,
I think it's a USB PIC model or whatever. Yeah.
You know, whatever the number is.
Lachlan.
Yes, Enrico.
The link you put in the chat goes to a not found page. Page not found.
Really?
I'm trying to do it again.
It doesn't like there's a like a registered trademark in the URL. I'll just I'll find another link, but this is a linear motor that we intend to use. It's made by a company just up the road, and it's like so it has 3 phases wound into that moving module. Hang on, let me post.
That link worked for me. I clicked it and it opened.
Yeah, but see, Roy, how it's got that registered trademark in the
but
URLs.
it converted it to %C2 %AE, and that gets
Now it
back.
works. Okay, the second one worked good. It's a PDF file.
Yeah, so these are like a high performance. They use them in high performance CNC. Like this company also makes CNC machines, like surface grinding machines for making like taps and drills and stuff like that. And they're using these as their what they call a forcer. So that whole module, that motor, is like got a 3-phase winding in it, and it moves along a magnetized shaft, and you can get good dynamic performance. I'll see if I can find the video. But it's just a simple, like it is a linear version of a
yeah, I would assume that they do that
servo,
so that
yeah.
I assume they do that because it's way faster than a regular style linear actuator, where it's a regular motor with a worm gear driving a shaft, right?
Yeah, I guess
it's like voice coil speeds if they really want to.
That's it. Yep. There's a video of it doing a. I'll find. Yeah, it loses, like you don't have a backlash of a gearbox in translation motion, like you do with well, a lot of systems, lead screws.
Yeah, those linear actuators are basically good to replace hydraulic systems, which I fight with once in a while.
Yeah, the only trouble is
the slow ones are not that. The one Lachlan linked you wouldn't use in place of a hydraulic system. It's designed for high-speed linear motion.
Ah, okay, yeah. So it's kind of more for actuators. I see.
Yeah, actuators. We're looking at replacing like a rodless cylinder or a pneumatic cylinder with it. And they're just like a sort of fast and accurate by comparison to maybe a like a stepper motor based system. The stepper motors tend to be a little bit slower, but
geared motors are usually slower than linear actuators.
Yeah. But one interesting thing about them, the magnet pole, like the pitch of the magnets, like the alternating north-south magnets on the magnetized shaft, is 50 millimeters or about 2 inches. So it's not like they're super, it doesn't have like a super dense magnetic pole arrangement. It's actually relatively coarse on the shaft, but they still get good performance.
But do they do, they probably do something similar to half stepping on steppers, right?
Exactly.
Where they turn on and off the coils at different currents to
that's it.
Halfway
so
between it.
They still achieve good.
That's why, like, most steppers don't have that many windings in them. They just do the half steps to get the higher step counts.
Mm-hmm.
Half, quarter, eighth, 16th, 256th now.
Yeah.
Yeah, those linear actuators are a little bit different from steppers, but basically the inertia is kind of different if you program them. So you have to a little bit change. If you change from steppers to with gears to kind of linear ones, you have to adjust a little bit the motion. They run kind of faster than you accept, kind of, because they are in a straight motion. You have to a little bit adjust the timing, and my experience.
I put a link with a 4-stroke motor running out of 4 solenoids. So imagine you're using such kind of voice coil motors to run the 4-stroke engine.
Introducing speech alarms.
A couple of weeks ago, I mean,
Huh, that's interesting. I'm seeing that video. So they're using solenoids to act like pistons.
Yes, makes a lot of noise.
But you know,
Yeah.
is there any design advantage to doing that instead of just having a rotating motor?
It's only a way to show it's possible to do. I wonder why it will be fine to use to a star motor, a certain simulated cylinders with a huge linear motor as the first cylinder and 12 other small linear motors to adjust the positional torque along the turn of the shaft.
Huh.
I think that's just a game to play with mechanics you can do, but I don't think it's a very efficient.
There was a motor from French. I don't remember exactly the name. It was demi-soupape motor, where the block of the motor is fixed to the helix. I don't know the name of the helix.
The engine is mounted to the drive shaft and the cylinders.
Yes, the camshaft was fixed to the structure of the plane, and the block of engine it turns with the, I don't know the name of the helix.
Yeah, it's the same principle with those now outrunner motors here, but Paraxat, where basically the axle is fixed and the tire is rotating around the fixed axle.
Yes, it's strange.
In that case, the whole engine was rotating in the plane.
Yes, because it don't use as a carburetor indeed. The block of the motor contains the fuel, and as the block rotates, the fuel is injected into the. Yes. There is a huge levers that move the valves at the top of the cylinders. It's very, very interesting. It provides a lot of vibration because of the deficiency of adjusting, but it's very, very interesting to see how it can do it.
Yeah. Yeah. I mean, I'm getting tired. I have the problem that I'm kind of working night shift, so I woke up at 5 o'clock in the morning, and now I went to bed at 5 o'clock in the morning, and now I'm tired again. So Chip, my friend, behave good. Try to get that floating point done. Yeah, floating point first. And the next would be getting used to Argos driver and do the debug windows on a P2. So that would be my wish. Producing a P2 program showing the debug windows on an HDMI or whatever, VGA, I don't care. Just use Argos video driver and produce your debug screens. That would be perfect. That's what I'm missing right now, because I want to get rid of those fucking windows.
Yes.
Being able to kind of getting rid of this. I mean, okay, and I even promised to write kind of a VPN here, VLC. I can get, if we have an PG Edge with 16, I can use Catalina and build a driver, and we have kind of a remote desktop to PCs, and else we don't need them anymore. You know, if we need them, we can remote tag into it, and else we can work on the P2. That would be really wonderful for my personal.
Yeah, no, I would like to do that. I would like to get away from the big machines.
Yeah, I mean, like your brother just told today, Excel update messed it up, and now you can't put space separated value coming from your inventory system into Excel, because Excel doesn't eat it anymore. Excel wants now pixel wide numbers for each column to import it, and here's his.
Yeah, it never ends. This kind of stuff never ends.
Yeah, and I you did that years over years, and now Excel is not supporting that bullshit anymore. I told him to use VisiCalc under CPM on the P2. He declined. Yeah. He declined. Yeah. But basically, it's working.
Well, I'm getting tired too.
Yeah.
I don't know how the rest of you guys are.
That's
Is there anything anyone else want to talk about? Like Brian?
Brian.
I'm a few hours late to the party when I heard you talking about the motor controller, and I was doing a little job with a pancake stepper motor and trying to turn this carousel, and because the pulses were so slow, the whole thing was this jerky, you know, clunk, 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 clunk. And I will confess, because I have to say it out loud, I was goofing with an Arduino for another friend of mine to help him do this. What occurs to me is that brushless motor controller you're looking at making, what could that be adapted to produce beautiful sine waves at 90-degree phase angles? And you could maybe claim that you could run stepper motors beautifully. Yep. Yeah, absolutely. Sweet.
Absolutely. Yeah, that's their problem. You're just switching them on, you know, one leg on, one leg off, and stepping it that way. So it gets to be really jerky. But yeah, if you could give that thing sine waves, it would actually become proportional.
Yeah, no, I mean, and the propeller is the way to go, and to PWM all that, and that's all beautiful. I just wanted to think about this BLD, if it's compatible for stepper as well, if you can sort of throw that in the line card or in the cell sheet, so that people don't think that it's exclusive to motors or brushless motors.
Sorry, I disappeared somehow for a minute, but I'm back.
Yeah, I mean, the controller has 4 bridges, half bridges, so it's really able to do 2 regular DC motors or 1 brushless 3-phase or 1 stepper, right?
Oh, sweet. Yeah, no,
that's I think the way it's set up. So that would probably be listed as features on the cell page.
Wonderful, good stuff. No, I joined 15 minutes ago here and I didn't hear that. Yeah, no, that's wonderful stuff.
Ken, do you know, have you talked to Michael? Because I've been out of the loop. Do you know where he's at on the layout for that board?
No, I have not chatted with them recently about that at all. I think maybe after the 1st of July.
Right. And you can't, and you said that the new P2 edge boards are going to be here on July 7th.
July 7th, and all the parts are coming on time.
Okay, good. So we're going to be able to build new P2 edges.
The mono-soup-up motor video is not linked at the chat.
Let's see.
So if you like weird things, you can see how it works.
All right. Ozprop Deb, did you have anything you wanted to say? Maybe he checked out for a minute.
Sorry, Chip, did you get your internet, your Starlink or whatever up and running?
No, no, it's still the same as I've had. That's why it's going in and out.
Oh, did you are you getting Starlink? Like, are you?
Right, yeah, we ordered it. I think they took $100 from us, so they're supposed to send us the setup and then charge another 300 or so, and then we start paying for it. And then but then we have really fast internet. But
yeah, you'll experience it much better than some people because you're out remote.
Yeah.
Some people are in cities and there's lots of people aimed at the same satellites, and so they're getting less than full performance.
Yeah, where we are, the population density is pretty low, so it should
and it'll be easy for you to put the satellite where it has full view of the sky in all directions with no blockers.
Yeah, yeah. Yeah, that'll be an improvement. Where'd my garbage can go? Oh.
Almost anything would be an improvement over the internet you have, Chip.
Yeah.
You have two cans and a string between you and Parallax, and it would probably be better.
Yeah.
Well, when this thing works, it works okay. The trouble is it talks line of sight microwave to a tower up on a nearby hill. And that thing is loaded with all kinds of equipment. And I think a lot of that stuff is always seeking around kind of auto tuning, trying to get better reception. And it winds up always stomping on our little band, you know? So I can call up the place and they'll change the frequency to something adjacent and it'll work for a while, but then in a couple of days it gets swamped out again. So I think other people are using some kind of adaptive thing where they're looking for free spectrum and they're switching around, and ours doesn't do that. They just have to set me to a certain frequency and then in time it just gets clobbered again. Hey, so would you guys be ready to get off this thing? We've been going for like 3 hours almost.
Yep.
Okay, for me.
That's
Please
okay with you?
remember to drink a lot of water.
Yes. Yeah, I'll do that. I'll do that. I'm trying to think of how to get rid of the bomb that I built, the big air tank.
It's really a problem, mainly because it was originally built on 1941. So it must have a lot of rust inside.
Yeah, I'm sure. Oh, it does. You can feel it. I was telling my wife, before I knew what my problem was, I literally thought I was dying. And I told my wife to make sure that thing gets separated and don't let anybody pump it up and blow it.
Cut it. You should
a single
depressure it
failure
and cut
of a
it.
valve. Please go ahead, Roy.
Yeah, I was gonna say you should use a grinder and cut it open, like
Oh,
cut it
yeah.
in half.
I have a plasma cutter. I was thinking what might be fun is take it to the back of the property against the levee and take an air compressor out there, then pump it up really high, then shoot it with a big rifle, right where we know the tension is greatest.
Yeah, make sure you're really far away when you do that, because the shrapnel
Yeah.
will travel very, very far.
I don't
Yeah, but it's
think it
probably
would make
fun.
shrapnel. I think it would
Well,
just,
it definitely will.
it would unfold.
It
real
absolutely,
quick.
it will absolutely throw off pieces, especially where the welds are at. It'll break off chunks and
I
throw
don't
them
want to do that
away.
because it could hurt. It could go on the neighbor's property and do something.
It's
Maybe
better to just cut it in
Yeah,
half
cut a
with.
hole. I'll just cut a hole with the plasma cutter. It'll just, I can cut that thing. But you know, I could convert it into like a smoker or something or barbecue.
Honestly, Chip, it's
So
your
also
life.
going backwards a step, you had another health issue recently,
Oh,
Chip?
well, I was getting like slowly, I didn't know it, but I had pneumonia and I was getting dehydrated and I was over days and I was just, it got to the point where I became delirious. I thought I was going to die. It was a horrible deal. And then we went to one hospital, the local one, and they checked me in, gave me some fluids. They go, well, it looks like you're doing okay. And we took an x-ray and there's some fluid by your lung, but it'll probably go away. And then that night, everything got really bad again. So my wife drove me to the real hospital up the road and they did an x-ray and they go, oh, you got pneumonia. And they just put me on antibiotics and I got better.
That's good. And dehydration is a big deal. My mom had an issue with getting dehydrated and collapsed while on one of her walks and got hurt from being dehydrated. So she drinks lots and lots more fluids now.
Yeah, I was scared. I had all these things and I didn't know what my problem was, but we had a cold snap here. It had been really hot and it got cold and I'd been outside working and stuff. And I think that's where it was not a good experience. I was really happy to get to this other hospital and they just put me on antibiotics and I became completely better, but I was worried that I had like sustained heart damage and I didn't know what was going on with me, but I was really messed up.
Yeah, well, lack of oxygen in your blood to your brain will do that.
Well, yeah, that's what happened because I had this pneumonia going for several days. It's like my TSAT was really low. My heart was like running at like 90 to 100 beats per minute. And I was slowly wearing out, you know, and I was dehydrated and I couldn't get straight. And I didn't know what was wrong. I thought I was in big trouble, but it was just pneumonia. I mean, they gave me antibiotics and that alone, that's all they did. And it completely fixed me.
Well, that's what happens.
Yeah. So now I'm back on that plant-based diet and I feel great. I've been out exercise, you know, walking a lot and I feel totally good now. In fact, I got you got on late, but I got so much energy that I started like cleaning my office. See, I've been excavating every.
We lost him.
Use a mask, please. Use filters in your nose. Use a mask so you don't get a lot of dust inside your lungs.
No, don't.
When did you get that drum set?
He is excavating his office after 10 years.
Yeah, there's the trouble. And half the dust went to Michael's house.
So Chip, when did you get the drum set?
Oh, I have like a bunch of these. We just was finding them on Craigslist. And my friend Eric, who was on this thing earlier, he's my neighbor. He lives down the road. He's a really good musician. He just got me some drums. And then we bought, I don't know, we just started picking up all these sets and I got one in my office. This is all the good stuff.
Yeah.
You know, drums are fun because you don't really have to have there's not much musical theory involved or anything. Anyone can kind of play the drums. You can have fun really easily without. We talked about this
I have a set of Roland V drums, which are they're electronic, but the V drums are the ones that actually have a mesh head, so they feel like you're playing real drums. The sticks have a really nice bounce off of them and everything. And then, you know, obviously the drum machine that makes all the different sounds.
Yeah.
I got
Yeah.
into drumming a whole bunch in the 90s when I was working at that company where we were making a music program and hardware. And a bunch of the guys there, we would jam every Friday night after work. We'd go into one of the conference rooms and we had drums and keyboards and guitars and whatnot, and we'd just jam playing music. And I was the drummer. I started out I would just, do a super basic doom, until I got better and started adding more to it. But yeah, I didn't have any training or anything. I just sat down and started messing around.
Well, yeah, you can do that. And then there are lots of neat YouTube videos of guys that teach stuff that is fun to learn. It's like really easy. It's like a high pleasure to effort ratio. Drums are pretty fun like that.
Yeah, my main issue that takes me a little while every time I go back to playing them is unsynchronizing my hands and feet. So like I can play with my hands pretty well or both my feet pretty well, but when I start using both hands and feet, I end up with my left foot and hand in sync with each other when they shouldn't be.
Yeah,
it's just
that's
motor
a
control
problem on playing drums. You have to unsynchronize yourself. Yeah.
But I also really like syncopated patterns on drums where it doesn't sound like it's regular, but it loops around and it is regular over a longer period of time.
Right. Yeah, there's a lot of neat stuff with drums. A lot of good drummers too that teach stuff pretty easily.
There's a lot of good YouTube videos of training you how to, do drumming and guitar and keyboard. Like it's pretty sweet. It's not when I was growing up, there wasn't really any way to get training other than to hire somebody or go to school. Right. Now you can just go look up a video and watch somebody train you how to do it. Sometimes better than the school would.
Yep. Yep. Yeah, it's amazing how just YouTube works and how many things you can learn, from all kinds of people.
Okay, well, I'm gonna bail. We're winding down and everyone's leaving, and you need to go get some work done or rest or whatever.
Yeah, I want to finish. I want to make some more movement on the office here. Get this pigsty rectified.
Thanks for the update, Lachlan, too.
No problem.
Yeah, thanks everybody for coming today, and we'll probably do another one of these soon.
Okay, see ya.
Thanks, guys.
Okay, thanks, Enrique.
See ya.
You.
All right, see y'all later.